IPM is already in development since 1995, as we know. It gained more momentum, this integrated pest management, in the 70s. And also working on these topics in fruit orchards mainly, it became very clear that if you want to do effectively integrated pest management, you really have to take a look at all the different elements of your farming system. Not only at the crop protection directly, but also at the type of cultivars that you are growing, the soil cultivation, ecological infrastructure, the fertilization, how you manage your vigor, etc., etc. So it became clear that for optimal IPM, you have to look at the total farm, and that's why it started to develop in fruit orchards, mainly in Europe, and it became like an integrated production system. Because if you look at all systems at one go, then you also can take into account other objectives that you have when looking at biodiversity or emissions of nutrients or other issues. So it becomes a multi-objective system, this integrated production. But it developed on the back of this IPM in the 70s. So this work continued in the IOBC context by farming systems research in Europe in the period between 1980 and 2000, and IOBC offered all the time a platform for this type of work. And this integrated production was elaborated as a concept and described. The IOBC has very shortly 20 working groups. They can be crop focused, or they can be pest focused or method focused, but it's basically a platform for scientists to meet on a biannual basis, very informal, very gray, you could say, to be able to exchange new developments in research and science. So that gives them a good network of experience. And this IP guideline of the Commission is originating from the point that we say, well, we have a lot of knowledge as an IOBC organization, we are working on the concept of IP, why not draw up a set of guidelines that we see as a sort of minimum that people can work with, because we noticed that there was a lot of interest in the definition of IP, but also what it is in terms of operational use. So we have two organizations that we, at this time, use our guidelines. It's a live organization here, of course, your organization, and TRECOP in Catalonia, which is a cooperative of fruit growers. And these are for us practical case studies, how guidelines are translated into practice, to see how it works, what comes up, what the problems are, what the different difficulties are, and it gives us feedback about the feasibility of the guidelines in the first place. So it's not our aim to have a lot of clients, but it's our aim to have some case studies that gives us practical experience in how IP schemes work in practice. So you have to get used to this. This guideline commission had as objective establishing this framework and guidelines and to support any organization that wants to implement it in practice. We have a website that you can visit on iobcwprs.org. There's a lot of information on this IPM, a lot of publications also. We tend to publish guidelines on all the different crops that we work with. We're just in the process of updating them all at once to have a new standard in 2015, but they are translated in different languages there. We also try to publish now and then on occasions different type of booklets like integrated production, objective principles, technical guidelines. That was published on occasion of a workshop in 2010. An integrated pest management booklet on different strategies in different crops, for a workshop in Brussels where Chris also attended for the 50 years anniversary of Rachel Carlson's Silent Spring. So these are typically the things that we try to do. The final sheet on this IOBC, these guidelines we notice are used a lot as reference in the international context. We have a lot of downloads, really thousands and thousands a year of that, as organizations try to orientate themselves on what are the next steps if I want to develop more sustainable growing schemes. And it's from the public side, subsidy schemes, or communication, or from the private side, like certification schemes. We have a toolbox with different elements that can be used by organizations, like the green and yellow list approach that you know from live, the database on selectivity of pesticides, an idea book on ecological infrastructures, and some software to to visualize the results of the inspection protocol. Well, now to sustainability, because that's the key issue for today, and I think that's really the issue of the 21st century. And I came here to talk to you about my view on sustainability. I've been working as a researcher for Wijnands University and Research Center, the agricultural unit in the Netherlands, for the last almost 30 years as a researcher devoted to developing more sustainable farming systems, integrated farming systems, organic farming systems, on as well experimental farms that I've been doing a lot of pilot farm work, working together in practice with farmers, extensionists, researchers, because I like that setting of different expertise, different outlooks on problems, different outlooks on solutions, that you really can work together to try to transform knowledge into action, into operational use, into creating impact. And that's what I've been doing the last 25 years on different projects. And from that experience, I want to share with you some ideas on which are the key issues on sustainability that we like to work on. The main focus today will be on biodiversity issues, because that was a special request of Chris to share the views and experiences we have in the Netherlands. And it's a lot to share, but I promise you that it will be somewhat less than the 1,286 pages PowerPoint presentation that this young guy, Aaron Petzer, put on internet. He's 30 years old. He's a billionaire. He sold his company for $170 million. And now he shares his young life experience at the 30th in 1,283 sheets on the internet. So anyone who is interested how it feels to be a billionaire, I think you can read it there. But still his main conclusion is, do something with your life. Make something out of it. Live a mission-driven life, more or less. That's what he already discovered when he was 30, so good for him. But it's easy to work with such an amount of money, I suppose. Well, every company in the world has, of course, a sustainability approach. I just to kick off, something from Unilever, a Dutch-based company that works worldwide, one of the biggest sources in the world. They source says 6 to 8% of all the palm oil in the world is bought by them. And their business directors say one of the challenges for them is to build a robust business in the 21st century that is compatible with sustainable development. And I like especially this second one, which is like a guiding motto. They say, we have to find ways to balance economic, environmental, and ecological issues, social challenges, because if we get this wrong, we will increasingly find ourselves in an unsustainable relationship with society, which is a very understated way of saying it, but basically it means, of course, we have to find a way to deal with all the public concerns that we also feel, because we are not only producers, but we're also citizens. We're also part of this society. So for them, sustainable agriculture is productive, competitive, efficient, while at the same time protecting and improving natural environment and the conditions of local communities, which is also a very important social aspect, especially if you look not only here, but also in other parts of the world. So Unilever believes that sustainable agriculture should support following principles, and many of these elements come back in any business plan on sustainability: high yielding, nutritional quality crops to meet existing and future needs. Resource inputs should be low. Ensure that adverse effects on soil fertility, water, air quality, biodiversity are minimized. Positive contribution should be made. Use of new non-renewable resources should be lowered, of course. And sustainable agriculture should enable local communities to protect and enhance their well-being and environment. So it's the social aspect, the environmental aspect, the ecological aspect that comes back. Here's my roadmap for today, and I'll show you this excerpt of this gold digger. And I hope you find some nuggets today in all the presentation that I will do of inspiration. This is taken from a mural of Diego Rivera that he made in the 30s in the stock exchange building. For Christ's sake, in the stock exchange building in San Francisco, in the middle of the crisis. In the middle of the richness, he depicted the richness of California on a big mural, and this is the gold digger. So the roadmap will show, I will share some sustainability issues with you, concepts and themes, and then come into the farm on especially issues on efficient resource use, energy use and carbon footprint, but digging in deeper into soil fertility, biodiversity and resilience, and then end with sharing some thoughts on what it means to be a sustainable producer in the light of society and the relation with markets, consumers and citizens. So let's just get this thing started. Sustainability are different ways of looking at things. Of course, you can say people, planet, profit issues. I think that's a very common concept. But you also can look at it from the point of view of capital. So that you say we have social capital, we have ecological capital, we have environmental capital. So we don't want to do things that deplete the capital, so that deplete possibilities for the future. Basically, sustainability is about maintaining the planet in such a state that future generations can make their own choice how to use it and have still the same possibilities. I think that comes back in every type of definition. But I also want to add to it that I see sustainability mainly, especially if you look at a farm, but in general as a systems challenge. It's not about one single aspect, all aspects are interrelated. You have to look at it from a holistic point of view, from a system point of view, if you start managing sustainability. And as we will see during the rest of the presentations, all these elements, especially in farming, are interrelated to each other. So you really have to have a complete view of that. Where I come from is from what I explained to you, integrated farming system. That's really what I've been working on in most of my career, integrated production. Starting in the 70s, as I already explained, it's a multi-objective farming system taking into account all these different things. And for me, being trained as an agronomist, it was like the most wanted thing to do, to work in this type of system, because you really can use all the different knowledge, because you work on crop rotation, on cultivar choice, on fertilization, on soil cultivation, on crop protection. So all the different elements are there. So you really are challenged as an agronomist, in the designer capacity. So to get your knowledge into designing new systems that are more resilient, more robust, more productive, but also less polluted. These are some definitions of integrated production, but I think I already explained that sufficiently. And we've been doing a lot of work then on that in the Netherlands. We had a lot of work on experimental farms, already started in 1980 with a large farming systems experiment comparing integrated production with organic production and conventional production. So to demonstrate different ways of producing, different ways of thinking, how you translate your care for the objectives into operational use in an organic system and an integrated system. We expanded on that in different areas of the Netherlands, in different type of crops, because we grow everything there, vegetables, nursery trees, bulbs, aerosol crops. It's a very intensively used country. 450 people per square kilometer, 16 million Dutch people on 80 by 150 miles. So there's a lot of people, a lot of cars, a lot of agriculture, a lot of export. We did a lot of work on pilot farm networks, working together with farms in different phases, also in a large network in the last 10 years more or less, on expanding numbers of farms and finally ending on a sort of network-based activities around sustainable crop protection, because that's really a big issue in Europe, in countries where agriculture is very intensive and pesticide use therefore fairly high, especially if you compare it to your situation. That's one side of the challenge. Then we have the challenge that is 8 or 9 or 10 billion people that will live on this planet in the nearby future. And that means we need more fibers, food, raw materials, agricultural production. And at the same time, this agricultural production is threatened in many ways all over the world because of soil degradation. It really takes place in a lot of places in the world. Salinification, acidification, adverse climatic changes leading to more desertification even, water shortages, long dry spells. So there's a lot of threats. At the meantime, we have to produce more and more. So that's a real big challenge for our near future, to increase and stabilize especially production under various conditions. This is a map taken from the FAO in 2000, and you can see the red areas where the soil and land degradation is very high. But everything that is greenish, there is some sort of land degradation going on. So there are not many areas in the world where this degradation is not taking place. And I think Oregon will be up here somewhere in the gray area. Fortunately, let's keep it there. My key thinking for sustainability in farming would then say, of course, farming is an economic activity. You cannot be sustainable if you're not economic. Profitable, you cannot do your investments in sustainability if you don't make an income or a profit. That's for sure. But it manages, farm activities always is about managing a complex agro-ecosystem with a large diversity of interventions, including the input of external inputs. And it should always refer to the ecosystem, agro-ecosystem itself. If you talk about sustainability, is that stable and sustainable? And is sustainable our adverse effect or our effects on the environment? And the social embedding. So mainly three things: the system itself, the effect on the environment, and the social embedding of the system. That these are the main components, I think, for sustainability. Which means, basically, further, that we have to work on further improving the quality production and with a robust level of quality and quantity. We have to optimize the resource use. It's a terminology much used in the world, resource use efficiency. So increase the efficiency per kilogram of produce, lower the amount that you have to use for it. Get less reliant on external input, try to mobilize as much as possible your natural resources in the cycles in the system. Try to minimize the emissions to the impact on the quality of water, air. And also, I think, minimize carbon footprint, because as we will see, agriculture is a main contributor to greenhouse gas emissions, but it's also can contribute a lot to the solutions. Then maintaining and improving soil fertility, which is very, very basic, I think, to the sustainability and to the continuity of agricultural productions and their communities. And maintaining and improving biodiversity. Then resilience is terminology that comes up in the themes of sustainability that I will talk on. And that's mainly how to deal with all this new pressure coming in from the outside. Adverse weather conditions, invasive new diseases and pests, and how good is your system in coping with that. And then, of course, sustainability has also to do with your social relations in your communities and your partnerships and in your chains, etc. First, resource use. An overview. We're talking about, there will be some redundancy in these sheets, so I will not explain everything. So I've taken them from different sources, try to weed out the redundancy, but there's still a lot of redundant wheat plants in it that I didn't take out, so I excuse for that. But still, looking at resource use is always about improving the production and efficient use. And it's about key issues: water, pesticides, fertilizers, mechanization, and labor. And in water, it's about efficient irrigation systems. We have a new terminology at our place in the university. We call it more crop per drop. That's something people like as a sort of umbrella terminology for the work we do on this topic. So also it's partly to do with the transition to hydroponics and greenhouse productions to increase the water use efficiency in some areas. Pesticides, IPM is of course the basic strategy for prevention and control of pest diseases and weeds. It's the master plan. The fertilizers, more efficient use, nutrient balance concepts, fertilization based on field-specific monitoring, mechanization, robotization to reduce labor input or to increase efficient use of resources, and labor itself, training and tools, because in a lot of places in the world, also the labor efficiency can be increased if you train your laborers correctly and give them the right tools to work with. Water is up first. Just very shortly, we know that the water availability in many places in the world is often low and limiting production. And according to the FAO, more than 50% of our available water resources is already used for irrigation and agriculture. So I would turn it the other way around. There's still a lot more to be used, but anyhow, this is fairly high. And there's a lot of infrastructural works to optimize the catch of rain, snow, and glacier water. For instance, in some areas in the coastal region of Chile, they do fairly well because they have built dams in time when they still have the money to do so. In other regions, they don't have the dams. In some regions, they have, you know, the irrigation channels are really lined, so they have less loss of water. In other regions, they don't have any lining at all, so they lose a lot of water through leaching through. So this efficient use of water is really imperative for the future. I really think this is a key issue that we have to work with. And I think in your conditions, if I understand it well, you have sufficient rainfall in the winter even to have up to, what was it, 50% of soil saturation in June. So probably you're doing quite well here. Hopefully we can keep it like that, because this morning a guy told me that in California they seem to predict a 20-year dry spell. So I hope that all the rain moves up here then. So it's about the techniques that you use, the timing and amount, and the more crop will drop. But also in some regions, like this example my colleagues work on, because Dutch are big in greenhouse production. If you compare an average field grower of tomato, let's say some place in Spain, to the efficiency that you can get in a modern greenhouse, it's a factor that goes from 40 liters that you need for 1 kilogram of tomato to 4 liters that you need for 1 kilogram of tomato. And theoretically, when you close everything and you don't have any losses, it can go down to 1.5 liter per kilogram of tomato. So it's basically water tomato, that's the point, of course. But it's very, very efficient, but you see that there is a lot to gain. So if you, for instance, work in the coastal region again of Chile, which is very, very dry, and they try to produce their tomatoes, it's really a challenge for them to think about whether or not to move into this more protected environment to use the water more wisely. And I know that there are a lot of people who don't like hydroponics, and it's not in connection with the soil, but this water challenge is really something that we have to think about and to consider this type of solutions. Pest and disease control, that's something we are all very familiar with, also in the context of life, IPM. We know that it will be a continuous challenge to produce high quality food and fibers under changing conditions with increasing efficiency. And I think pesticides are going to be for a long time part of this crop protection package if we are to produce on a high level, on a robust level. I don't think we are yet able to produce without using pesticides on the required intensity that we seem to need for the planet and for these 10 billion people. So the master plan strategy is always, of course, IPM, has always been, and is always accepted now also as the official strategy for crop protection in the European Union as of 2014 is IPM. So even to the extent that they say, well, every farmer in the European Union has to use IPM as the starting point for crop protection. Well, that's easily said than done, but anyway, it starts with the intention, and then we can work our way through operationalization, of course. And of course, you know that it takes all natural resources, minimizing external inputs, etc. That is the EU perspective on pesticides that I already told you about. It's a powerful tool. It's an ongoing challenge to minimize the side effects. So they say IPM is the basis, but they have a strategy that they call reducing use and impact, the Sustainable Use Directive, which is on itself a strange terminology to me, sustainable use of pesticides. But it really means how can we deal with pesticides in such a way that we can use them in a responsible way and make them part of our system without losing them because we are irresponsible in the use. It has all to do with impact on the environment, to reduce them. Basically, it's a pesticide risk reduction policy. The issue of integrated nutrient management, I call it integrated nutrient management, just a fancy terminology to explain that is of course an integral plan for the whole farm. It's based on, of course, worldwide, I think now acknowledge that you have to work with the concept of nutrient balances. Input is output, plus unavoidable losses that you try to keep as low as possible. But nitrogen is let me say, the bull of the herd. He's wild and unpredictable in terms of mineralization, and in terms of when it is available and when not. So we need more. Of course, we base it on mineralization patterns throughout the year in a certain system that you also have, of course, in your vineyards. But then we have to look carefully on a yearly basis what is exactly the level of nitrogen that is available in this season, because it has been very dry or very hot or less water. So you have to look at the status of your plant or your soil tissue or your soil. And I think we're already doing that, taking into account the further uptake and expected soil mineralization, to be careful about the amount you use. And I think in vineyards that's imperative because of the vigor issue. So you already work with that concept very strongly, but I can assure you that a lot of field crop growers don't have this problem of vigor. So they really have to find another rationale to limit their amount of nitrogen. So it's very much about limiting the potential emission that is strongly increased when you use too much nitrogen, of course. What was the last one here? Let me see. So minimize losses of nitrogen, keep it in the system, catch and cover crops, especially in the winter season, but you have that already a lot on the green cover in your vineyards, of course. And buffer strips to avoid runoff. But catch and cover crops, if you go a few states to the east, it's still fairly new concept to have anything more than bare soil in the winter, I understood. So it's still something that a lot of field crop growers can learn about. And especially for rotational systems that I've been working in, it's really a challenge to get these nutrient balances right, because there are 4, 5, 6 different crops that you grow in a crop rotation, all different in demands for potassium and phosphorus, but still on a rotational basis, you try to keep this nutrient balance going on, but you have to make choices where to apply the phosphorus, mainly to this crop or not to that crop. So it's a sort of balancing act over the crop rotation. And it's also tuning the rhythm of the short-term nitrogen mineralization that occurs when you have a certain pattern of crop rotation with the inputs of nutrients. So that's also a challenge, but it can be done. Energy and climate is also an issue that I think that came up the last 20 years as a strong sustainability issue for farming. It seems, I was looking at this yesterday evening and this 40%, and I didn't believe it, so I looked it up again on the internet, but still, it seems to be true. 40% of the Earth's surface is used for agriculture. I cannot believe it, but I see people nodding in the... Well, let's find out again, but there's a lot of area. I directly found a hit when I put this sentence into the Google. Agriculture contributes strongly to greenhouse gas emissions, but it also can mitigate climate change, and it has to adapt to the effects of climate change. It's of course about the different greenhouse gases like carbon dioxide, nitrous oxide, and methane, and it's all, when we look at the nutrient cycles of carbon, it's a big cycle that involves, of course, the high amount of carbon in the oceans, but also the nutrient cycle through the carbon dioxide and the respiration, etc. You can look at that from different points of view, and I think there are still a lot of different points of view when you talk about this topic of carbon footprint. A lot of different opinions how to calculate it, what to take into account, where do you put the boundaries of what you take into account for your system or not. So this is just to get some ideas, to maybe help you think about this topic. It's about, of course, this carbon dioxide, nitrous oxide, and methane. This is about the fossil energy, but it's also the organic matter balance in the soil. When you burn off organic matter, it gets a lot of carbon dioxide in the air, but you also can store, sequester carbon dioxide in your soil when building up organic matter. Nitrous oxides is more or less unavoidable It's a sort of biochemical side pathway of all sorts of mineralization, denitrification, nitrification processes. There's always a side product, and it's more or less unavoidable because that goes into the air, but there's a strong contribution to the greenhouse gas emissions, and especially agriculture is very strong in methane emissions from cattle all over the world because they produce a lot of methane. They are like small methane factories, in fact. A little bit from pigs and from the manure there, but a lot comes from the cows, of course. And then you can calculate the carbon footprint of a farm or a process, I will show you, based on carbon dioxide equivalents. And then you see that nitrous oxide has a 298 times strong effect than one equivalent of carbon dioxide. So it's a very strong greenhouse gas, somewhat less strong. So you can calculate them as equivalents of CO2. Agriculture really contributes to these two. So if you look at the European Union, main contributor in these two greenhouse gases is agriculture on the European scale, but also I think worldwide. So you can, again, you can calculate on a lot of different ways. You can say, well, look only to the fossil fuel, then you say that primary production, for instance in the Netherlands, takes 5% of the fossil fuel use of the total nation. Of that 5%, more than 4% is greenhouses. It's a choice we made in the past, but it's a very intensive use of fossil fuel. But it produces also 80 tons of tomatoes per hectare, or let's say 30 tons per acre. It's a lot. If you look to the agri-food sector, so also every chain partner that works for agriculture to create inputs, but also to process your food, then already the fossil fuel use goes to 15%. And if you take into account all those customers that drive their cars to the shops and buy things and distribution and logistics, then the whole food sector gets up to 25% of the fossil fuel use of the nation. If you express it in greenhouse gas emissions, it becomes higher. So then you see that the primary agriculture is already 15% of all the greenhouse gas emissions. Agri-food sector goes up to 25%, and even with the consumption. So the whole food business, the fact that we eat, that we produce food, that we need that, is contributing unavoidably to, of course, greenhouse gas emissions in the world. So it's not a question that it is wrong, but it's a question how to deal with it and how to mitigate these greenhouse gas emissions where possible. And that's mainly by working on these topics. I can extend, we've been working in a project with farmers on this for many years. So I could extend, but I will not extend farther than this, on saying that it's basically on energy saving and substitution with sustainable energy. There's a big challenge for gasoline, of course, how to deal with that in the future, or how to substitute that. It's a big contribution. But also you can work on reducing your import of production, like fertilizer, fodder. That also has a feed print, you could say, was produced elsewhere. For instance, in the Netherlands, we have a lot of animals, but we import feed from Southern America. So the transport, but it's very dependent on how efficient it is. It's not the ship that is the problem. The ship is very efficient. So large sea containers, fuel use, if you calculate it per kilogram, is very low. The biggest problems are the old trucks driving 200 kilometers through the jungle to the ports, and then the damage is already done again, because they already did the damage by cutting the forest in the first place anyway, and releasing all these enormous amounts of carbon from the soil. But okay, so to reduce the emission of methane and nitrous oxide, there's a lot of things you can do in animal husbandry, of course, even with methane, but also in soil cultivation and fertilization. Burning off your carbon is not a good thing, but also using a lot of mineral fertilizer also contributes to a lot of losses of nitrous oxides. And then, of course, there's a possibility that you sequester CO2 in soils and a long cyclic biomass. And this is something that is, of course, like a sort of, how do you call it, it's a deal scientists made. They say, well, we can only calculate CO2 fixed if it's standing longer than 50 years. So the crops, your annual crops, or even your perennial crops don't count. It has to be longer than 50 years. But it's also the other way around. If you use wood that's less old than 50 years, it doesn't contribute to your carbon dioxide problem because it's in the calculation seen as an internal cycle. So a lot of things that you can do on a farm level, and I think in the future we will see more work on this, to be able to calculate footprints of a farm. I also saw that this farm was already working on this topic. There's a certificate on the wall if you go to the restroom. But it's becoming more important, and I think we have to be aware of that and look for possibilities to contribute. Then, we are moving into the major topics of soil quality, biodiversity, things. So the first topic up is soil quality. Let me just take a sip of coffee. And what I showed you here is something that I came across on an art exhibition. And this artist is called Claire Pentecost, and she represents the humus in the soil as gold bars. I thought it was a brilliant idea to really visualize the infinite value of a good soil quality, of good humus content, that's at least as worthful, because valuable, much value as gold is. Again, we are facing a lot of soil deterioration, degradation in the world. These are typically corn producers in the Netherlands. They used to be very rowdy. They harvest under every condition. They don't care because corn don't seem to care. But still the soils are degrading very much. By all these different causes, of course, machinery, compaction, erosion, mining, salinization, lack of organic matter supply, that's a big challenge. And I think a lot of international sourcing companies are seeing this problem in terms of soil quality. Because, for instance, cacao production in West Africa, there are not so many young people who are willing to produce cacao anymore, to get into cacao production because their fathers are doing it and they don't make much money. And they don't make much money because they are depleting the orchard. They are not getting anything back into the orchard as organic matter. So companies that source cacao, like big companies from the Netherlands, we are not only selling a lot of stuff, we are also like, how do you call it? We are the directors of the major streams of cacao, tea, coffee in the world. But these companies say, well, we have to help those people there to get their soils in order, because otherwise, if it's not profitable, people will be out there of production, and we will be out of our sourcing material. So for their own sake, they start investing in the southern parts of the world in working with soil fertility. There's also a lot of American companies that are doing that now. So I think it's taking responsibility of the things that you source to also invest in local communities and local sustainability. Decline of soil biodiversity, etc. So FAO and UNEP see this as a serious threat. Again, this map, of course, that we saw already on the degradation. But then, a little bit philosophical point it becomes, because soil is the basis for food production. We need further intensification, as we saw in the 10 billion challenge. Soil is a key factor in the resilience of the whole system against all those stress factors. If you look at water retention, water penetration, soil biodiversity, soil resilience, soil disease suppression capacity. So we need a lot of pluriform functionality, robust performance, and as this guy, David Montgomery, argues, without fertile soil stress, no civilization, in his book Dirt. And I think that's a few states more to the east, in the Dust Bowl, where they experienced this, and where a lot of gold diggers came from, of course, when they went to California, because they were out of business in the 30s, partly because of this problem, but partly, of course, also because of the economic climate. But still, sustainable soil management is something we really have to take care of for the future. Well, little fellows, there's a lot of things that are called nowadays ecosystem services. I don't know if you came across this terminology yet. So your ecosystem performs services for you or for us, for as consumers, as producers. But it's of course, the soil is of course the supports the productivity, the biodiversity, possibility to deal with climate change, water regulation, also even detoxifying aspects or cleaning up water. So there's a lot of things that soil do for us. And if you look at sustainable soil management, what do we want with it? We want to maintain and improve soil quality, supporting that multifunctionality, of course, of the soil performance. But we also like to prevent, of course, the further degradation and erosion and support robust production systems. So it's all about how to do that. But it's always in a certain farm-specific conditions, because soil is not something you can manipulate to endlessly. You have to work with what you got. I don't have to tell you. You're a specialist in that. So you always try to optimize within your own conditions this sustainability. The key management strategies are based, I think, if you work on sustainable soil management, you should work on organic matter management and on soil cultivation. So it's chemistry and biology and physical, and organic matter ties them together with different properties. And organic matter plays a central role in this whole quality of the soil, because it influences many different things: the binding capacity for nutrients, the mineralization capacity, the decomposition, the cross formation, the workability, the structural stability, the nutrient availability, the buffering potential, retaining moisture. So many different things that organic matter is connected to, that it's really the key player in the soil. Together, of course, with the biodiversity, but that comes from having sufficient quality and diversity of your organic matter and sufficient physical space. So working on for rotational crops on a good crop rotation, looking at the different inputs of green manure, crop residues, mulches, that are the typical inputs that you get from your own farm. Then, of course, nutrient management, looking at organic matter imports. What do I use next to a mineral fertilizer? Do I use compost or farmyard manure or whatever I can lay my hands on as organic matter that's useful? But also, if you look at organic matter management and soil life, or pesticide use is important, because some pesticide use can destroy your soil life and has an adverse effect, of course, also on your decomposition of organic matter. And soil cultivation is an important aspect to look at the intensity, the depth, the degree of mixing, I would say, in your soil. So there are many different ways to manage your organic matter. Then the soil cultivation aspect. I think it's, I'm very much a fan, I suppose, of non-inversion tillage, because the Dutch seem to be addicted to plowing. So we have rotational systems with a lot of root crops, potatoes, carrots, all things that grow into the soil. So we tend to love the possibility to make a lot of fine soil, build ridges to avoid water stress, too much water in it, and to be able to harvest them and to clean them. So it's understandable that we like plowing, because it's one of the ways to get all this soil, heavy soils to crumble and to being able to work so intensively in. But I don't think it's the future, because it's costing a lot of fuel, of course. It's very labor and fuel intensive machinery, but it's also destroying a lot of soil life, because it's all the time the stratification of your soil is put upside down. So an organism that is living in 30 centimeters is up there again, it has to see its way back. There are all sorts of dangers going back. So you lose a lot of biodiversity by this plowing. So I'm a fan of non-inversion tillage, but working your organic matter more into the topsoil. And from long-term experiments in different parts of the world, you really can see that it increases in general the water holding capacity. It starts with a better water permeability, so the infiltration capacity, because the big corridors, or how do you call them, the pores, become more stable through the activity of the earthworms, especially the ones that go up and down, Lumbricus terrestris. But then it also, because the structure becomes more solid, there's more capacity in all these finer pores, so the water retention capacity increases, which is also a very good thing. Both contribute to a lot less erosion problems on hills, wind erosion and water erosion. It encourages soil life. It gives more buildup of humus in your topsoil layer. By that also keeping more nitrogen into the system. But it has one big disadvantage in general, because we didn't plow for nothing also. We did also plow for getting rid of the weeds, especially in systems where you have all these grass weeds or this mowing crops, cereal-dominated rotations, corn-dominated rotations. You have, of course, these very persistent grass weeds. We only can get rid of them mostly by plowing, because if you plow the seeds into the cellar of the it's very cold, wet, you lose 90% by moisture and degradation of the quality of the seeds. But if you keep them all in the topsoil layer, you have a real problem. So mostly, it tends to be that not plowing systems in the world are also herbicide addicted. And that's why I think also in the States this use of Roundup has been so widely used, because this is an advantageous system from a large point of view. People use it, but they don't cope with the weeds in a mechanical way. They just use the herbicide. There seem to be people that think that this herbicide problem is copable with. I also think so, but it's not easy. I'm not going to deny that. But this guy, Theodore Friedrich, works as a senior officer for the United Nations Food and Agriculture Organization, and he has a brilliant presentation on sustainable intensification, as they call it now worldwide, this need to increase your productivity, but with conservation agriculture. That's the terminology I think you're familiar with, that you also use in the States. And this is what he says about it. He says, from a contribution on a congress that I took from him, he says, first 2 years are critical when changing over. Yes, for sure they are critical. If you don't get your weeds controlled in the first 2 years, you will have a problem for the rest of your life, because it's very dangerous to change over and don't control your weeds very perfectly. The rest is more or less, I think, common sense. So the herbicide used in the beginning is equal, but it's slightly increased, but it declines over time. That's what people say that are doing long-term this type of work. But also I don't want to withhold you that he also says some notable things about conservation agriculture and climate change. So an additional benefit. It's mitigating through emission reductions, less fuel use at the long run, less nitrous oxide emissions, because this higher, better soil structure gives less anaerobic conditions, and anaerobic conditions give nitrous oxides. So it's better also for the greenhouse gas emissions. And it's also building up carbon in your soil to a certain equilibrium level, but building up this is also contributing to mitigating. And mitigating potential of soils in the world is very, very big. Also in comparison to the total greenhouse gas emissions. So, and the application is better because it's, as I said, weather conditions, moisture is better retained, and it's better infiltrating. So people seem to agree on that. This is something that I forgot to say. This is an outlook somewhat broader than your vineyards, because this is not directly applicable, but indirectly you're already doing this, because most of your vineyards you will probably only work in the topsoil to get your mulch incorporated. So this is basically something that is a little bit outside of your wine producing, but it's going on in the rest of the world. So what we try to do in rotational crops is then to combine this non-inversion tillage with systems that I would call fixed tramline systems, where you drive always with GPS on the same place. And you try to work as wide as possible. And your tractor width is, for instance, 3 meters. And then you try to avoid compaction of your soil with the same purpose, to increase your productivity, because the soil is not compacted, to have better mineralization, even a more easy weed control in not compacted soils, even mechanically, You have also the possibility of this mitigation because you don't have these anaerobic conditions. So we really like to work on that way, but we're still looking for trying to develop solutions for the harvest problems because you cannot harvest, let's say, row crops with a very wide machinery. So we have to work on that to avoid destroying again what we build up. But still we use this, let's say, seasonal fixed tramline systems until now, but we like to make them into fixed tramlines for perennial things or for over the years too. So this is in Dutch, but what it shows is organic matter management is influencing, of course, the fertility, the pollution, the water management, the climate change, the biodiversity, but it's also influenced by crop choice, nutrients, and crop protection management and soil cultivation. I think we're getting to understand that it's always the same thing that influences it. It's biodiversity, it's soil, and it's your crop management. So here is an example of the long-term experiments we are doing at the moment between the plowing and the non-plowing. This type of tractors that we use. So let's move into the key topic, the biodiversity and the nature and landscape issues. And you see if I'm still on track. I think so, yes. Well, we have all those little friends, especially these type of species that are very public friendly, markers of quality of landscape or in biology. But the biodiversity in agricultural landscape, and it seems like I'm complaining all the time, but also this, like soil quality, is going in the wrong direction. There's a strong decline in the last decades, and it's really related to the intensive use of fertilizers and pesticides, but also it's very strongly to the rationalization, so the scale enlargement, cleaning up the field floors from unwanted elements that are in the way of our machinery, so the landscape elements become less frequent, scale of fields and farms become bigger, and the production conditions become more and more uniform, so there's less diversity in your soil, as was in the past, of course. This is a global concern, not only because the loss of species in itself, because that's considered a value on its own. We shouldn't lose species because we don't know for sure what they're doing and what they are contributing. So why eradicate something that we don't know what its purpose is? So we should keep them, loss of species itself, but also loss of biodiversity as a natural resource. So we are losing the potential, we are eating up the capital. In terms of fish, it's really like that. 95% of all the world's seas is technically overfished, or how do you call it? Too intensively fished. But it's also a global concern because of the decline in ecosystem services. Because all this biodiversity, also in the soil, as we saw in connection to this organic matter, really contributes a lot to the stability and the quality of our soils. So all these different things that biodiversity does for us is also in decline. And that's something we don't want, because then it's really functional. And then we get upset about it. So, biodiversity in agricultural landscapes is still in decline. And let's say the strategies that are used in Europe, mainly, I suppose, or let's say the most important things that we try to do in Europe is work on, let's say, alternative management practices, but focused on the non-productive areas. So they say we are going to work on biodiversity on a farm, but then mainly on the non-cropped area. So like a sort of marginal thing in the farm. Field margins is a hot topic for the last 10 years, but it's often not effective enough, and I will explain why, and it's not very widespread. So in spite of all these projects that have been done all over Europe, and all these these years and all these subsidies that has been given, it really is like a drop of water on a hot plate. It doesn't really help very much to stop this decrease. The decline of, there's a lot of decline of fauna, for instance, that is really related, of course, to the diversity of biodiversity of insects, especially skylark populations and partridge populations. Skylark populations are going down. Partridge populations are going down even by 95%. And even in the landscape in the Netherlands, there are 25% less flowers. I don't really know how they count that, but anyhow, you should imagine a governor from someone from government driving around in a car. 1, 2, 3, 4. Probably took him 13 years to count them all. So, but anyhow, it's dramatically 95%. So there are 3 levels that influence, of course, on a scale level of biodiversity, on field and soil. To start with your own farm, of course. You have your own management practices that influence the biodiversity. As we saw, the management of your soil, the use of your pesticides, the crops you grow, your inter-row management, your green manures, your winter soil cover. All these things contribute to potential different habitats, shelter, food and breed possibilities for all those different flora and fauna. Also the corridor function for moving from one end of the farm to another. That's on the farm level. I don't know if that's the right terminology, Chris. Veins, what we call it, green-blue veins through the landscape as a corridor function. But they have to be managed in a certain way to have a certain quality to be able to function as a corridor. Not just something to walk on or to run over as a rabbit, but also to have feed, shelter, breeding possibilities. And on the regional level, of course, I think someone mentioned that yesterday also, you cannot have a lot of biodiversity if your larger landscape is very empty of biodiversity. You cannot be an oasis in a desert. There is always in ecology a connection between what you do on your farm and what is happening on a larger scale in the landscape. So how can we work with that? We need more biodiversity, but especially the species that need crops or farms as a habitat. They provide, of course, as we saw, I keep on repeating that, that's a redundancy, essential ecosystem functions, pollination, soil life, nutrient cycle. And it's biodiversity that really contributes strongly to the resilience of systems. Because if you have a lot of different biodiversity, we really think that your system is better able to cope with adverse conditions or with stress. Because there are a lot of different mechanisms that will help to overcome that. Based on, of course, the diversity of your flora and fauna. So, all these different things is what these ecosystem services provided by your biodiversity does for you. Of course, it's an attempt to show that it's really worthwhile keeping them. Pollination, pest control, nitrogen fixation, even, right? Clovers. Mineralization, it contributes to organic matter decomposition, soil resilience, soil structure, water retention. All these different things have a strong relation with your biodiversity. And on the right-hand side, you see then, of course, it comes from pest control. If it's functional biodiversity, it can help you to control your pest or eventually to reduce your pesticide input, etc. And anything that it has a star there as input potentially is coming from fossil fuel use and potentially can be mitigated to their use by dysfunctions of the biodiversity. There's a strong relation between the biodiversity under and overground. Is that correct? More or less? Subsoil and... anyway. So there's, of course, the fertilization, crop rotation, cultivations that build up organic matter. That is a basis for your soil life, like earthworms, There are the springtails, the mites, the nematodes, the bacteria and the fungi that interact and decompose all the organic material in different order, of course. Then this is part of your complex that is the soil suppression of diseases or your soil resilience. Then on the topsoil, on the layer, you get these carabetes and spiders cleaning up, and that gives you more natural pest control on your aphids. So this is more or less how your system is connected to each other. And that is, if you talk about soil biodiversity, when you look at it, then it's about the species, the numbers, the activity, and the different functions, but it's, again, a repetition. This is a way of representing it in the Dutch scheme, in which there are different levels of decomposition, organic matter. The first layer, the second layer, the third layer, and the fourth layer, or something they call it. But anyhow, as you can imagine, it's like a pyramid. So it's eaten or be eaten, but you have the first insects that decompose the raw material that comes directly from the plant, and then you have a next generation of insects that take over and eat them, or the final material that they leave behind, etc. So it's really a very complex food web. Bacteria and fungi. Very important for also, is this something you would understand, mucilage? It's slimy stuff that sticks, that they produce, that helps the aggregate formation and the pore, and brings in the pore volume. And of course we know that earthworms bring a lot of organic matter in the soil, they mix it, they have horizontal, vertical corridors, they have water drains, etc. So there are multiple functions of the soil life. Nutrient delivery and the root exudates are feeding into the soil, into the community of the soil biodiversity. It helps to build up your organic matter, also with the input of fresh organic material. Of course, in decomposition, we have all these sort of emissions that we have been talking about. Also, nitrate, of course, is as a mineralization process, but nitrous gases go into the air, and carbon dioxide and methane. It contributes to your structure, your disease suppression, and moisture and air household. I think it's fairly clear that it's a very important function of this soil life. And that you can influence it, rotation, soil cultivation, liming, etc. So, the higher the diversity, the more ecosystem services there are in general. More diversity, more ecosystem services. And the more diverse the system is, the higher the resilience is against stress. That's a little bit like a postulation, or how you call it. It's logic, but not easy to prove. So what can we do to the operational side? And I'll give you some examples that we've been working with in the Netherlands, and I'll be fairly honest about them to show you where the pitfalls are to work with this. And it's not pleasant, fully, this story. Because you have to first, our ideas has always been, and I think it's the same around here, we should create an ecological infrastructure on the farm, and that's really what I mean in connection with each other. So the connectivity of different landscape elements, but also connectivity within your farm of all these non-farmed areas is very important for wildlife. They really need to be able to move around and to connect from a farm to the wider landscape. So you have to find out where your landscape and your farm connect and how you get more or less. You should think like a mouse and think that you're on your farm and try to get out because there's a hog. Where can I go? Which different routes do I have? Where can I connect to this bush that is over there? Shit, I have to cross open land. Now I'm lunch, yes. Exactly. Let's have another break. So look, it's like a physical foundation that you lay, this network. But it's, at the end, the effect stands or falls with the quality of that network, how you manage it, and what is the result of your management. I will talk a little bit later about these landscape ecology terms of connectivity and circuitry. But if you have this infrastructure, you should manage it very appropriate, specific to the objectives that you have. It makes a lot of difference if you just want buffer strip for reduction of emission of pesticides or catching runoff of nutrients. Or if you want a buffer strip or really a biodiversity strip. It requires different management. Then on top of that, of course, you have to take into account or give an additional focus on landscape elements. And I see landscape as something that we humans, as a sort of definition that I can relate to. The landscape is recognized by us as a certain landscape because of the repetition of characteristic elements. So elements that are very functional in your landscape, that are always there, we should look at them. Can I use them again on my farm? Can I increase more or less the frequency of natural elements? Give them a place, offering wildlife, shelter, feed, breed opportunities. And don't forget about your own farmyard to that. It also offers a lot of opportunity, like nesting boxes for the way you manage your hedgerow, or your wood stable, or whatever, or your bee hotel you can even produce. A lot of things that you can do. But basically, the structure and then the function. I think Nini called it also yesterday, that structure and function. So, infrastructure management is the precondition. I've already told you that it should be a smart design from the regional point of view, where it strengthens the connections. And the functionality, of course, of this structure is that it brings together these natural elements, the travel zones, but it's also the buffering and the ecosystem services of the functional biodiversity. And in countries like the Netherlands and some other West European countries, they think if you have good buffer strips, or it's also recreational. You can, like farmers' pathways, biodiversity walks, you can do things with that to the public. So it's about different elements in the landscape that you try to connect to each other. So there are many different things that you want to do with this biodiversity. I told you already about the buffering, diversity in general, red list species, that could also something that you are very interested in to protect, or food shelter in general, or and different targets that you can have. And I stress that because you have to be clear about what you want with your infrastructure and your buffer strips or field margins, or what you like to call them, or ecological compensation areas, because your objective determines what you have to do as management. This is, I think you get the picture that the Netherlands is very flat. It's very, very flat. Our highest point is 350 meters, and it's only in one spot in the Netherlands. The rest is more or less even. And we, like I said, God created the world, and the Dutch made it themselves. We reclaimed it from the sea, and there's a lot of water everywhere. So we have a big issue with emissions of nutrients and pesticides because there's waterways everywhere. And there tend to be, the tendency of field margins is in relation to the sides of the ditches, of course, because that's a natural site where you would like to get your field margin in. So you see different examples of field margins as in different projects and ways it is managed. But you see a lot of differences. You see grass strips where it's driven on, you see flower strips, not indigenous flowers, but just seed sown flowers, all sorts of different stuff going on. Not very high diversity or value from the ecological point of view. In the dreams of policymakers, it's a very, very valuable thing, these field margins, because they say it's good for the quality of the environment, for our biodiversity, for the connectivity in the landscape, for clean water, for landscape quality, for recreational value. So it's like a dream of a policymaker, and that's why they do all the projects. And they try to bring the money in and give subsidy to farmers to do this. And farmers on their own, and I think I'm not telling something here that is astonishing, farmers on their own are not so inclined to do this. But if it's a project and they pay for it, well, okay, why not? And then you are joining in the project for 3 years, then the money is gone, the project is gone, and then you get into business as usual. You clean up what you sometimes even call the mess. And you get into agriculture. So for farmers, it's a different thing. It's a question how to manage it and how to deal with eventual risks from these margins or the infestations that come from it. Or is it even a shelter for my, not only natural enemies, but my enemies? So is it the danger for my crop? And is it also, if I get a subsidy scheme, it's a lot of administrative burden and paper pushing and regulations and people telling me what to do and what not to do. So for farmers, it's a different outlook, I suppose, than for a policymaker. So I'm exaggerating both, I suppose, but there are different ways of looking at the world. But these field margins, they start nice, but they can turn out very different than planned. For instance, you can sow in an annual flower mixture, but grass takes over. Or here, it was a grass buffer strip, but it was a wet autumn and we had to drive somewhere. And here, we have to clean ditches, because otherwise they cannot stream. But this way of cleaning, scraping it really off and putting all the material on top of it, is not the best way to maintain biodiversity in this side of the ditches. So there are all sorts of problems what we have. So this value can be created in this infrastructure with focused management, but then you really have to work on it to start, I suppose, in most cases, to export the mowing, to get it off, to deplete your nutrients, to get a poorer situation. And if you get a poorer situation, you also get rid of the weeds, because most of the dominant weeds in agricultural systems are nitrophilic, or you call it nitrogen addictive. So if you get to a depleted situation, then of course the weeds competition will be much lower and flowers can take better over. But when you mow also, this is a difficult point. Our farmers don't like it, and they don't do it a lot because it's costing a lot of money and where to leave the stuff. And you have to have other machinery, etc., etc. So it's not easy to do this. That's one of the reasons that these field margins are not very successful in terms of biodiversity. Farmers don't do this. When mowing, you have to, of course, leave alternative patches open, so that there's always something flowering or pollen, giving pollen, and to, what we call that simply the bar for insects that they can feed on, the bar or drinking. The bar must be open all year round, not only in spring. And you get a dry summer spell and you go to an alcohol anonymous. No fertilization or crop protection, because then you destroy or stimulate the right things. And these strips should not be used as roads. And then it starts becoming complicated. Because then you have a biodiversity strip and you cannot drive on it. So where do you drive? On the next strip. Oh, so I'm not talking only about 3 meters, I'm talking about 6 meters. So, but this is the honest truth. If you want to reach something, you have to think in this way. What is the objective? What's the field margin time? How do I create that and manage that? Can I monitor the results? That, of course, give feedback to my management. And can I evaluate and document the effect? That would be the proper way of doing things. The rationale. But, of course, it's often less conceived. It's just something we do. Field margin, flower strip, let's get it in. If you want to have water quality, then it's about buffering of emissions of nutrients and pesticides. Then you will have to look for, it's always along waterways. 3 meters would be effective, as we can show, and you have don't fertilize or spray it. You can have an additional objective of biodiversity, but then you have to decrease fertility by the timing of the mowing, and of course putting it off, and you have the difficulty with the cleaning of the ditches. But this is the way of thinking for this particular point. And of course we know from research, with research, But of course the drift of pesticides is already down to 25% when it's up to 90% when the buffer is 3 meters. So it goes fairly quickly down. So with the spraying technique in open crops, 3 meters is already very much contributing to the reduction of the residual surface water. It doesn't help very much for the nutrients because as you can see in this diagram, the lateral flow of nutrients is coming with the water flow also from much wider than 3 meters. So it helps for runoff, but it doesn't help for lateral transport inside. If your target is biodiversity, and often it's not the main target, then you have to look for more chances for flora, birds, butterflies, mammals, but then you have to look at what are your target groups and what type of vegetation do I want? And how do I get that? And how do I manage that? And then you can have a secondary target in landscape quality. But I think that's why I put in these question marks. Some citizens seem to like these flower strips, but I don't think they belong on a farm, sown flower strips. I think you always should think about the indigenous species that were there and that you try to promote them, not some mixture that you bought and just put in because it's a fancy site. It looks very artificial to me. Not to the most citizens, they like it when they see it, but when I drive through that type of countryside, then I think, what is going on here? There seems to be a project that is subsidized. And biodiversity, when you really want to show results, it's fairly complicated because you have to monitor. And monitoring is not easy. It's costing money, it's laborious, and you have to do it for a long time to really show that it has a real impact. You can only monitor the results after a few years. But you have to look also for flagship species that you can identify with, like the skylark for open crops is really like a sort of species that you can relate to, so that people can have an impression. And we have fairly big successes, for instance, with a very large bird of prey that was almost extinct in the Netherlands, but it has been repopulated in this area because of strips of 6 meter width that were very effective for more insects, more small birds developing, chicks of pheasants and partridges, etc. So, for the farmers it's about feasibility, we discussed that, limit cost and labor, limit risks, and find practical solutions. How to deal with weed control, how to work with machine, how to export the mold material, how to combine that with ditch cleaning, so it's not an easy task. And then we start talking about functional agrobiodiversity. And I think on the background you see a picture from the Soter domain that I took from internet, Soter, where we were yesterday. Soter domain that we saw yesterday. Functional. Functional agrobiodiversity is of course about how it helps us in controlling pests and diseases. And of course these field margins are very important, landscape elements, flower strips. And we aim of course at increasing level of natural enemies prior to or at the offset of an epidemic. Because the problem now is of course an epidemic starts, natural enemies develop because the feed is there, but they are too late. So they have to be already as a basic population present. So when the aphids come in, you can start preying on them and cope with their development. There's still some Dutch terminologies, but of course we are familiar with natural enemies and pests, and also with the way it would work. Normally exponential growth without any intervention. Aphid development in cereals, they come in and they explode. But if you have already a field margin with a certain population to start with, they decrease the development of the population, and then in-field natural enemies take it over because they have sufficient capacity to work with the rest of the population, because here the population is too high to control. And then you get many situations in which you can keep under the damage threshold by this approach. Just to give you an impression of the Dutch farming landscape in the polder area in the wintertime, we get snow occasionally, and then these crawlers, these natural enemies, they overwinter in roadsides, ditches, field margins, and the flying fauna goes to bushes, hedgerows, unmanaged land. And then, of course, in spring they come out again from the roadside, the ditches and the field margins, into the field. That's the crawlers, let's say the carabid beetles and spiders. I think 150 meters is even optimistic. Some of them only run for 10 or 20 or 50 meters. So field size is an issue. But of course, these flying insects come into the measurable effect even up to a kilometer when they come from different sites from these bushes and hedgerows. And they are commuters, more or less, between the field where they prey on of course, on the pest, and to the field margins where they find also nectar and pollen. But in your vineyards, they probably would also be able to find nectar and pollen within the vineyard, depending on how you manage your inter-row strips. That's how it works. Does it work? Well, in a long-term experiment that we did with different levels of diversity in the field margins, we have a red one that is the system without margins, the green one is the system with margins, and this is about the percentage of suppression of pests in comparison to control. So it's a real monitoring of the population. And you can see 46, 40, 29, 38, 56. So fairly high levels of suppression of the pest development in field in a situation with margins in comparison to a situation without margins. But I have to say, the field size was also adapted in this situation. They're fairly small fields. So the larger the field is, the more difficult it gets to control from the field margins into the field. Then you have to do something also in the field. So on a larger scale experiments in the polder area in the Netherlands, again, 4 arable farmers together on 1,000 acres. On cereals, potatoes and onions, we did monitoring from 3-4 years and support the farmers in their crop protection decisions. Here you see where they put in this case, the flower strips in the purple. Then you can see where they put on grassy strips as another option within their farm. And the results will show that there are more natural enemies in the field margin. As a result, less aphids in cereals and potatoes and less use of pesticides. A clear relationship between the number of natural enemies and the soil cover giving nectar and pollen, population development, and this gives you the impression in blue for the control and green for the participants in this experiment that sprayed lower frequency of pesticides. So this is one of the few documented cases that it works. There are not so many documented cases that it really don't. And as I said, there's this restriction of this large surface of monocultures. And this type of functional biodiversity coming from the margin has a limited effect. So what to do? Then you could say, well, we have to increase or enlarge our basis for functional agrobiodiversity by taking new things into account. We have to increase the stepping stones idea, that we have larger natural reserves within our production area, like a repetition of landscape elements, natural elements, that are like stepping stones, beetle banks they call them in the UK, very friendly terminology. Carabid beetles like it, they are colonizing there, they run into the field and come back. So can we manage that? Flower strips, but also the infield diversity is something maybe for the future. We're not only talking about, but when we talk, for instance, on inter-row strips, like you already do, but then more managed for natural enemy support. In viticulture, that's your privilege that you have already this situation to work with. And it's more difficult for these poor rotational farmers. And the landscape level is something that you can use to increase your functionality of biodiversity by really embedding it in the larger landscape. To really look at designing additional elements to what is already there, or to improve the management at a landscape level. So in dialogue with your neighbors and with the community, to see how can we increase on this landscape level of biodiversity so that also through the corridors they can colonize or recolonize my farm again. This is something we have been working on as an idea on this landscape level in another part of the Netherlands. These are like one farm, so this is about 20 farms, back to back. Flower strips as an idea that you could put in on certain areas. Then enlarge it with the farmyard green that you manage for biodiversity. Then you can think about the original, already there, forest and bushes, the edges of it. Then you can say, well, we have also a lot of waterways, and some of them are what we call eco-friendly river banks. So they were steep ditches, and they created shallow edges and meandering things, and so it's also there. So can you use this at a landscape level? And also the management of the roadsides. Also there we have an opportunity to do different things. We never were able to start this. It's only an idea. Finance is still lacking, but it would be nice to be able to do so. And working in a network, looking for synergy. The costs are also spread over a larger community, but it needs dialogue. It's a community thing. And it's important, because in landscape ecology they have terminologies that are like connectivity and circuitry. I really would like you to understand them. Connectivity is about the extent of connection between landscape elements. How intensely linked are they to each other? I will show you some examples. So, connection. And circuitry is the extent to which it is possible to move from one landscape element to another through different links or pathways. Very abstract, and I'll show you a picture. But the last terminology is an ecotone. That is the length of the transition zone from one habitat to another. So if you have a long bush, and you have a lot of field margin beside the bush, this transition zone is very, very valuable for biodiversity. But just to give you a picture, the little mouse again is here and wants to go there. In this situation, if you create a corridor only here between four different, let's say, landscape elements, then these are four different links, then this mouse he knows that there is a falcon here, so he goes in this direction. He has already an alternative. Two ways of reaching the finish. If you have an extra strip in between, then there are already four ways, if you think about it, how you can get from here to there. So you can walk like this, you can go like this, you can even go, etc. So it really explodes if you have more connections. The different ways that you can walk in the landscape, or disperse yourself in the landscape, as wildlife. That's, in ecological terms, a very important concept, that you really have to connect the way that your different landscape elements are connected, because they should be connected also like this, and like this, and they're all connected to each other. That would be the ideal, but it's not possible, of course, always. And look at the way, the different routes that you can take from one side to the other. So these terminologies are called connectivity, circuitry, and they have a very fancy calculation, which is too complicated to explain, but it looks like this. And it's something, if you are bored on a Sunday afternoon and want to get your head cracking, you can have a go at it. To get your board and make a design. But anyway, it's about this concept. There is a group in Europe that is working on this landscape level issues. It's attracting a lot of scientists. This group is about 60 to 80 people. It's a landscape management for functional biodiversity group. But it's like a very huge basket of all sorts of interests in issues around pest control, landscape management, ecology. But it's a new thing. It's fairly new. It started in 2003 and they meet every 2 years. They met this year in Poznan in Poland. So just to remind you, biodiversity, soil fertility, resource use efficiency, they are all, of course, linked to each other. Well, as a more or less final step in this biodiversity story, and I think this is an Oregonian landscape, again, robbed from the free internet. Beautiful landscape. Things come together more or less in the concept of resilience. Resilience is a concept that says, like it is in definition, the capacity for self-repair or adaptive renewal once disturbed. So you have a system that is in a steady state, you have a strong perturbation, disturbance, and how fast does your system recover? And does it ever recover to the original level of stability and production level? That's the terminology resilience in ecological science. Well, so it's about biotic and abiotic stress, new pests and diseases to cope with, extreme weather conditions. And we need this resilience, I think, as agriculture to cope with these conditions and to support really stable and robust systems. For you guys, quality is even more important than quantity. Obviously not the other way around, but quantity is also important to start with quality. And for much producers in the world, it's very important to have a sort of stable production and not being 1 year high, 1 year low. So this robust production has something to do with this resilience of these systems. And key elements are, of course, again, the same thing, soil quality, because it's all about the soil and about the biodiversity that will help you to build up this resilience. And it's about the diversity of the biodiversity, of course, but also different communities, the continuity. And also the way you manage your farm. If you're, for instance, fully managing a farm based on control, so pesticides, fertilizers, heavy machinery, instead of agroecology, probably you will be more punished by that in terms of resilience, because your system will need more of that input to cope with all the different factors that will influence it. If you have more a system based on agroecology, working with nature, working with biodiversity and soil quality, your system will need less external inputs to cope with these adverse conditions or to work with. Sometimes you wonder why scientists get paid at all. For sure not for drawing out pictures. And even they have the same name. Ehrlich and ehrlich. Well, it's almost like Eastern German science. Well, anyhow, it explains fairly well that the stability is, of course, related to the species richness. And here is this exaggerated picture of how you can do things conventionally, fully based on pesticides. I think there are systems like this, yes, in America, but not in your country, of course, not in Oregon, not in mine. But you have to build it up, your control, by using all these different elements. You use IPM, building on variety choice, in some cases variety choice, you don't have always the choice, of course, it's random. Field dimensions, banker plans, crop rotation, farm hygiene, pesticide use, they're all different elements that constitute together your crop protection as a holistic approach, as a system approach, as opposite to the conventional one. And you can also express it in a picture. I think most of the conventional systems are in a dangerous state. They try to protect their ball and it's on the hill. And they have to keep it there with force. Okay, we can go down to a natural system that is very much stable, agroforestry. Then this ball will roll, but always comes back to the middle. But what we try to do is create a system that produces on a very high level, but still has a certain stability in between two mountains, more or less. The ball rolls on a high level. Yeah. So we've been discussing this. This resilience comes from diversifying and increasing and maintaining biodiversity, not only over the whole farm for food, shelter and habitat, the landscape elements we discussed, the ecological infrastructure, but also the field size and dimensions matter. And then something comes that my colleague is very passionate about, from which I took this presentation. He's very passionate about in-field variety. So he thinks that there are much more to be reached if you look at, for instance, genetic variability, variety of crops inside a crop rotation in time, but also at any given moment at the same time in the same field, like mixed cropping systems. That's very important maybe for the future. And it's also not only about continuity of these, all these habitats for the different natural enemies, but it's also about discontinuity for pests and pathogens. So, is the host always there? Is that a repellent function? Is the pest confused because what's going on? Where's the salad? Unfavorable habitats, and you can do that by crop rotation because frequency and sequence of crops, but also by intercropping. You can create discontinuity for your host plants, the attractivity for your pests and pathogens. So, intercropping makes more efficient use of resources in general. That is often seen in these type of experiments. But it has also positive and negative interactions. It's always a question of a balance, but it reduces the host abundance. So this is the same for an outlook to the future, not so much a practical possibility, because there are a lot of difficulties in practical terms when you try to deal with these type of mixed cropping systems. But ecologists keep on coming up with this all the time. Because in epidemiological terms, there's a logic to it, as you can show. There's host abundance and diffusion. But in agronomic terms, I personally am not very much in favor of it. So my colleague is, and there are different opinions to that. I can see from your reaction that that is also true in this room. Because it's very difficult in markets because of the demand uniformity. They're not used to this biodiversity, mechanization, and field operations are not easy. It's an economic and policy. Promote uniformity in general. Research focuses on different types of solutions, so it's not easy to work with. But in general, talking about this resilience, we have a lot of stuff that I've discussed that we know already about and can be used. Field margins, flower strips, reduced tillage, cover crops, organic matter balance, mixed cropping for fodder crops, under sowing, even this mixed sowing that you do in those inter-row crops between the inter-row management of your vineyards. So there's a lot of things that are already viable to put in place, and for the future we need maybe more research into this type of strip cropping or agroforestry type of thing. It is an agroecology concept that has to be developed further. Well, still a lot to think of. So, a lot about biodiversity, soil quality. Really have to, I think, come up with a plan for farms. So your own biodiversity plan, how to manage it, and to be clear on what you want, how to connect to your surroundings, how to deal with your natural elements, if you have to put more in place, if you have to split more or less fields. Have clear ideas about the objectives and clear strategies for the management. That will be something for the future. I think that is even, I've been discussing with Chris, that is much more important than the percentage thing. It's not about the percentage, it's about the quality of what you're trying to reach. But the percentage thing, the 5% that we've been talking about, of course, in the scheme, is something to start with. Because then you have to think about where to and how to. But it's only the beginning. I would be more satisfied with a good plan and a good management that really brings something in terms of impact than with the percentage. So that's something that we probably will be discussing this afternoon, Chris, to see, or discuss later this morning to see how we can manage this topic to the future in a way that is maybe more pragmatic but also more effective. Finally, I want to end with a small outlook on market, citizens, and consumers. If you are, like you guys are doing, working with sustainability and you try to make it a characteristic of your community, you say we together try to, or are working in a sustainable way, and we want to show that, we want to open up to the public and to the society, then also, of course, the things that you are doing are very important to create a standard and an independent certification. That's an excellent tool to show to the communities, to the outside world, to the markets, that you are doing something differently and that you stand for it. That there is a certain impact of it, there's a certain quality level to it. But if you do so, it also means that at the same time that you do that, you have to take, you did already, take responsibility for sustainability because you claim it. So that means that everyone can address you and can challenge you and can audit you or can come up to you and say, what are you doing in this topic? So you become vulnerable, but you also have a responsibility to deal with sustainability issues that come up. You cannot neglect new things. So if a new discussion comes up in society on certain aspects of farming, as a community you have to think about how are we dealing with this in our sustainability scheme? How can we explain what we do? How can we also give a rationale? So it means taking responsibility, which is excellent, but also being accountable, so transparency. Also in terms of opening up in the website, like you already did. Everyone can see what the standard is and how it is worked with, which is really excellent. And you have to have a careful argumentation. For instance, we had a lot of talks on dialogue, Chris and I, on, for instance, some elements. During the season, a new pest comes up, you need a certain pesticide because you cannot control it on another way. And this pesticide is a very bad one. Let's say a red list one, you could say. Has an adverse effect. Well, I said to Chris, the most important thing is always that you have to protect your production. Sustainability cannot be about losing production. It cannot be about losses more than 1%. So you have to, if there is no other solution, you have to use that. But at the same time, being responsible means that you acknowledge that it is a problem that you're dealing with, and that you show how you deal with that. That you really try to look at and make a sort of audit. Are there different ways to deal with this problem? Are there different preventive measures that can be in place? Is there another type of strategy to solve this problem in the future? And if you have looked at that, you always have an answer to society. And if you looked at that and you don't find a real good answer, you can always address the research people, because that's the real thing that they should be looking at. And not only being interested in their own stuff and writing for the libraries of science, but doing the work that needs to be done for the problem of the real communities that try to produce in a more sustainable way. So, and you have a strong argument because you're already taking this responsibility. So I really think that researchers should be listening very careful. Maybe they do already very well here. Maybe it can be improved. Your certification gives you an enormous transparency for the consumers and the citizens, but it's also an ideal vehicle, of course, to showcase the approach as a community, what you are doing, and to communicate with very different groups, because it gives you a more or less a legitimate voice in a number of new processes, new partners that you can get on the table, researchers, public authorities, other NGOs, maybe new alliances that you can benefit from, because you made a choice. You took responsibility for development. That's, I think, a beautiful thing. So you build up a larger network. So these achievements give you a voice. And this standard also enables a professional dialogue, which I know that it's not always easy, because you differ from opinion, of course, because you're farmers. You wouldn't be a farmer if you were not headstrong. So there will be a lot of arguments, but what you do is you create a framework to discuss it with each other. And that gives direction. And it's a professional dialogue that is then possible between growers, managers, and researchers. And that's what we do. That's what I experienced yesterday in the field visit already, when farm managers, wine makers, vineyard owners, when we were talking and discussing different things. And the standard also has in it, and that's a very good thing, the possibility to develop. So, the sustainability, social aspect is really about taking this responsibility and connecting. The two, connection and responsibility, are very important, I think, for the future. And you do that with society at large, and it gives you can see that this is really a lot of typing errors, the last one. Regional communities that you can build on with this approach, and to these consumers of wine that will always be dispersed everywhere. So it's more different from, let's say, local vegetable producers who have more or less a customer base that is locally identified. But you, with your quality wine, you will end up having consumers all over the world. And that's what you want, because you're proud of this and you want to sell it everywhere. So I think Life is a real pioneer in doing this. I think it's great that you have this community that does this. And I'm grateful that we also have one of the founders of Life, Alice, here today. So this is an acknowledgement of all these things that you have been doing in all these years, this growth of this community. And I'm very happy that I can be at a distance to your service in developing the concept. And I think you should be proud of yourself to do so. So thank you very much for your attention.
Frank did a great job of introducing a lot of the subjects I'll be talking about today and providing some context. It was really fabulous, especially since we didn't talk at all beforehand. So it worked out pretty well. Two key things, themes to continue through those discussions. The first is that just to honor the work you've already done, the fact that you are all participating in this live experience is a pretty tremendous undertaking, and it says a lot about the character of folks in this area and what your interests are, and the fact that you're already thinking about systems and complexity in terms of on-farm management. And so that's something to take forward. The second thing is systems. I teach sustainability at Oregon State and in a variety of different contexts. And that's one of the early foundational concepts we introduce. The first aspect of sustainability is systems thinking. And Frank brought that up pretty well, thinking about just in terms of on-farm, but then enlarging your concept of systems to the surrounding landscape. And that is the critical piece of biodiversity that I'll be focusing on right now. If I can, there we go. Oh, I understand why you're struggling with this. It's very sensitive. There we go. All right. So we do have to start on the same page a little bit. And some of you are pretty familiar with concepts of biodiversity, some not so much. And so I want to spend a little bit of time just making sure we're on the same page. Because biodiversity, like sustainability, has a lot of different definitions in a lot of different contexts. So we could be talking about species richness, and I think in many of the cases where Frank mentioned in his presentation, he was referring to species richness, which is simply a number of different species in a particular location at a given point in time. But there are some other really important aspects of biodiversity which influence, to a great degree, species richness. And genetic diversity is one of them, thinking about the genetic variability of genetic characteristics for a particular species, which is very, very important, thinking about maintaining a population of a particular species through time, whether it's on farm or in the surrounding landscape. And then a great piece of that, which goes back to that conversation of heterogeneity and having different habitat types, both on and off farm, is ecosystem diversity. And that's really about the different habitats you have across the landscape and their relative abundance, their size, and their configuration, their relative spatial configuration. And they're all three relevant in terms of vineyard certification systems and biodiversity protocol within those certification systems, because you can't achieve this one without also having those two in place. Okay, so there are lots of different on-farm biodiversity initiatives you might approach. And what you do, as Frank mentioned, should be driven by objectives. What you do on farm from a biodiversity perspective will be driven by those objectives. So you could be looking just for on-site species richness. And you could be looking for specific insects. You could be looking for plant species richness, a variety of different things. You might be doing that for aesthetic functions. So some of the flower stripping Frank mentioned earlier could be just for aesthetic reasons. And sometimes that can be beneficial functionally, and sometimes it may not be. Or you could be managing for on-site functions, very basic functions like soil protection. You could also be approaching this from a regional species richness perspective, so that what you do on farm might be under considerations of regional species diversity in terms of support. Or you could be focusing on regional functions, focusing on key species as part of a larger framework within a regional perspective or a statewide perspective, depending on what it happens to be. And none of these are mutually exclusive. So you can focus here, you can focus here, and also be hitting these as well. So I am an ecologist by training, so I'm going to talk about things in terms of theory, and these just happen to be two important theories. But before we even get there, I want to just see, can any of you identify this furry little guy down here? If you can see that picture.
Pica?
It is a pica. Where'd that come from? Excellent. Why am I including a picture of a pica in a presentation about vineyard biodiversity? If you can make this linkage, I'll be really impressed. There isn't really one. But there is a linkage to some of these theories in terms of species populations through time and whether or not they can be maintained through time under changing conditions, particularly in the case of pica, climate conditions. And we've learned some things very recently from research on pica about some of our theoretical foundations for biodiversity at the landscape scale. So I'm going to talk about that a little bit today. But one of these theories is really important, particularly in the context of where habitat improvements occur and their spatial relationships to other like habitats if we're trying to improve species richness across the landscape. And this theory was developed by a couple of pretty notable ecologists, and essentially came up with a couple of different take-home messages. The first is that distance or isolation, relative isolation of a particular habitat in a landscape context matters in terms of biodiversity. The more isolated a particular habitat patch is, the less likely it is to support high species richness over time, because you don't get a lot of movement of individuals between areas. And another piece that came out of this is that larger islands in an island context tend to support higher biodiversity than smaller islands, simply because you have more habitats through time. That led to some application in the ecological literature of this whole idea that if we want to maintain biodiversity from a conservation perspective, then we need to focus on single large reserves rather than several small reserves. But we have learned much more recently that that's not necessarily the case. In some cases, for certain species, single large reserves are really important. But for other species, several small but highly connected reserves can be equally valuable. And that's particularly true for insects. And so that becomes important for this conversation. Another piece of theory which is important, and Frank touched on this a little bit as well, is thinking about how organisms feed and the types of habitats which are required to support populations through time. One theory is optimal foraging theory, which essentially predicts how any organism will pursue food. That we make decisions about the kind of food we eat and how much of it we eat and how long we spend eating it based on environmental and biological constraints. So if you think about environmental constraints, one major constraint is distance, and that speaks directly to the edge effect, the edge to interior effect Frank was mentioning for vegetation strips at the edge of fields. If they're too far from the interior, because the field is very large in size, foraging by those insects is only going to occur some certain distance from the edge. And so that becomes a really important environmental constraint. Biological constraints can vary. It can be things like cognitive capacity. Some organisms have great problem-solving skills, so they are able to forage more widely than others. Some organisms develop really interesting habits like pika do, where they will gather their own food, but they'll also steal food from other pikas, and that's just an advantage they have to increase their foraging capacity. Okay, so building on that last slide, it was a great transition slide. There is some evidence, although it is pretty new, looking at the relative influence of on-farm improvements for biodiversity, both for biocontrol objectives and sort of broader biodiversity objectives. And I just want to share with you some of the work. You may be familiar with David James out of Washington State, doing a pretty good amount of work looking at farms or vineyards where there has been work to improve native habitat, so really focusing on native plant species for that particular region and comparing those to conventional vineyards. All this work so far, at least in the report, is in south central Washington, so a very specific ecosystem type. And again, it's been driven by focus on native plants, so not looking at non-indigenous plants, which may have other purposes. And there's some general results. The first is that in vineyards where native habitat has been reintroduced in patches, they tend to see reduced pest abundance and increased beneficial insect diversity and abundance in those vineyards. And then just as a side category there, diversity and abundance of butterflies as key pollinator species also tends to be greater in vineyards where native habitat has been restored. There are a couple of important caveats there, and it goes back to theory again. So all of these plants that were evaluated in this work were growing in nearby natural areas. So we're not talking about isolated situations where we reintroduce native plant species, but there's nothing in the surrounding habitat similar to that. So that again points back to me to the island biogeography theory. So if we think about that, we can only apply the results of that particular work to situations where you have some degree of habitat connectivity. If we were to do the same kind of thing and create this really beautiful native habitat restoration area on a vineyard that is isolated by maybe 3, 4, 5 kilometers from the next nearest patch, the relative biodiversity value, the functional value of that habitat is much lower than if that property is closer to existing habitat. So that's a really important point. The other thing is, whenever we start talking about ecology, and this is something I share with my students all the time, the minute we start talking about rules and generalities in ecology, the species about which we are discussing does the exact opposite. And so you have differential impacts by plant species. So we can't write general rules across ecosystems. What works in one particular location as a plant species that is a host for beneficial insects probably does not apply necessarily to another area. And different plant species attract different insects. So one of the really fascinating things about David James' work, he found in that particular ecoregion that sagebrush, the lowly rangeland plant, that's my background so I can say that, attracted the greatest number, total abundance, of insects. But that was primarily in one guild, and that's parasitic wasps. But when you look at some of the other species, these are all forb species, northern buckwheat, clematis, snow buckwheat, and milkweed. They attracted a greater variety. And so the take-home message there is a one-size-fits-all approach isn't going to work at either the site level or at the landscape level. You have to be thinking about combinations of different plant species to attract the widest variety of different insects. So I spent a great deal of time combing the literature on on-farm biodiversity improvements and relationship to the landscape scale. And it is a relatively new field, but we're starting to see some interesting results. And happily, a lot of that does support some of those long-standing theories. So this is one big take-home message. Proximity to natural habitat has a major influence on on-farm biodiversity results, regardless of whether or not you're using low-intensity or high-intensity methods as the farm management approach. And there's a great deal of variety in terms of the ecosystems where we're talking about. Some of these are in South Africa, Spain, Italy, the United States. So this work is occurring all over the world, and we're starting to see convergence in terms of the results. Another one, and this is a great shortcoming right now, is that many of the studies we find in the literature have been conducted in areas where there is already relatively high rate of plant species endemism. So you've got native plants in the area. So what we don't know is, are a lot of those findings applicable to areas where you've seen a dramatic decline in native plant species? And we find a lot of that in certain areas of the Willamette Valley. And if we go down to California, we see even a greater extent of changes in native plant species diversity. So that becomes a pretty important opening in terms of research. Another one is that disturbance is important. Frank mentioned mowing, particularly for the strips. And mowing can be an important disturbance that can actually help to maintain diversity through time. That one is related to a hypothesis, which you can take this as a grain of salt. I put intermediate disturbance hypothesis in there. There's a lot of recent literature that indicates that that hypothesis only applies to about 20% of the experimental findings. So what we do know is that disturbance at a broad level is an important component of maintaining biodiversity through time. There's also a lot of literature that suggests that species response, particularly when we're talking about different insects, to on-farm methods varies by taxa. So we see that beetle response is very different from spider response to on-farm biodiversity methods. And again, that goes right back to the point of establishing very clear objectives for on-farm biodiversity improvements. You have to have a good sense of what it is that you're trying to achieve, because the response in the biological communities will be different based on what you do on-farm. So how do we interpret all of that mess? There are some things that we can take as nuggets. I love that soil. Call it that soil as gold brick. If our economies would be very different if we valued soil that way. Natural habitats in close proximity, very important. And that's both for establishing populations of desired species at a point in time, but it becomes even more important in terms of maintaining those populations through time. From quite a bit of the experimentation, what you can see is initially you can attract desired species right after a project is implemented. But through time, as population dynamics unfold, it becomes critically important that that on-site population is able to interact with other nearby populations in order to maintain what happens on site. The size of the patch, going back to the percentage discussion, may not be as important as how connected the patch is. So you could have a very large improvement on farm, but if it's very isolated, the relative benefit from a biodiversity value may be pretty small. The good news about that is there's a flip side. Small patches, which mean less in terms of giving up production space, can be pretty effective for certain species. On-site efforts can improve species richness without improving function. So you can have species richness with certain insects and they may not actually do much for you, either in terms of biocontrol or contributing to functional biodiversity at the landscape scale. So again, it goes back to being very clear about the objectives and thinking through the functions you're hoping to achieve. And what it all boils down to is that anything that happens on farm has to be part of a coordinated regional approach. Frank mentioned dialogue as a really important component of moving forward in those very high-intensity agricultural landscapes in other areas. And in this particular sense, if contributing to regional biodiversity is important, it means connecting on-farm managers with folks off-site, government, number of different entities into a greater, more coordinated conversation. So we specifically started looking at some of the issues related to how to make the existing protocol for biodiversity alive is using a functionally driven approach. And so we started with this lit review, looking at on-farm biodiversity strategies and the results in different areas. And we determined that one of the really important things to guide the discussion, it goes back to the objectives, is to utilize a framework for discussing biodiversity and driving the actions that may happen on farm. So happens that in Oregon, we have the Oregon Conservation Strategy, which is a starting point for moving forward with a more functional approach. And we overlaid this Oregon Conservation Strategy and some of the existing data associated with it on a number of pilot vineyards, a sample of the member vineyards, and split that in ecoregions. So if you think about live membership, you've got vineyards in the Willamette Valley ecoregion, you've got members in the Columbia Plateau ecoregion, and you have members in the Klamath Mountains ecoregion. That's important because each of those ecoregions has distinct climate, soils, and topography which dictate the species you have in those areas and the specific plant communities you have, which will influence animal movement and all sorts of things at the landscape scale. It's also important because what you do in one ecoregion may not be relevant to another one. So across-the-board approaches are going to be very challenging. So we utilize this Oregon Conservation Strategy as a platform. And there are a number of different species listed under the Oregon Conservation Strategy as strategy species, target species. And we looked at all of those and where their habitats overlapped with vineyard production areas. And we looked at those species. Not all of them are necessarily relevant. So, for example, one of the Oregon Conservation Strategies is coastal cutthroat trout. Most of the vineyards I was looking at in this pilot study do not have perennial stream sources going through the property, so it's largely irrelevant, even if the habitat zone indicates that's a strategy species for that region. And so we went through and we filtered out all of the species which would not be relevant for that particular on-farm context. And that gave us a smaller list of species at the ecoregional level, and then we used that to research specific habitat requirements for species that might be relevant for on-farm biodiversity improvements, and then compile a list of habitat improvement types that could occur on farm that might support this larger statewide conservation strategy at the ecoregional level. You following me so far? All right. I don't need to go over that. You're all familiar with it, ecological compensation areas. And the reason I put this in here is there are a couple of different objectives, potential objectives listed in the existing terminology, including promoting biodiversity wildlife corridors and or habitat for beneficials. So we're looking at biodiversity already from a fairly broad perspective. So we can interpret that further in a couple of different ways. this is already part of the existing live literature, promoting a functional biological control for common agricultural pests via beneficial insects. But we could also be looking at creating beneficial habitat for Oregon conservation strategy species, for example. We could also look at improving and creating habitat that provides ecosystem services, e.g. pollinators with native bees. So we could be looking at a variety of different levels which will dictate what we do on site. So if you're not familiar with the Oregon Conservation Strategy, it's a state-approved multi-party initiative. It's very high-level work to identify key species and key habitats at the state level in different ecoregions which were worthy of protection and prioritization at that scale. And one of the important things is it identifies ecoregions within the states based on those varying habitats and ecological communities as a driver. That may be one of the most useful aspects of the strategy. So if we look at it, a lot of the vineyards in this area occur in this Willamette Valley ecoregion. And it's a broad ecoregion. Obviously, we can subdivide that into even finer ecological levels if we want to. But this gives you basically climate and topography driven. Then we have the Klamath Mountains ecological province and the Columbia Plateau. That's where the pilot vineyards were all located. And within each of those ecoregions, there are strategy habitats listed as conservation priorities. So for the Klamath Mountains ecoregion, Klamath Oak Woodland is a conservation priority as a habitat type. And so we can use that and identify, okay, what are the key native species associated with that particular type. And then Columbia Sagebrush Steppe for Plateau region, and then here in this ecoregion, Willamette Oak Savanna or Oak Prairie types. And so we can have that as a baseline to drive some of the biodiversity decisions we might make on farm. There are a number of different OCS species listed for each ecoregion. I just selected a few here. Townsend's big-eared bat, Kincaid's lupin, and Finder's blue. These two should have a whole bunch of lines connecting them since they are interrelated and interdependent. And then there are a variety of different bird species as well. So what we did is we took that Oregon Conservation Strategy approach and we boiled it down into a number of different species based on ecoregion, which would have the greatest potential impact on OCS species, but would also be relevant for a vineyard application. We broke that down into these ecoregions. So, for example, we started to compile a list of plant species that could be used for native habitat restoration on site. And those species are directly keyed to Oregon Conservation Strategy species and habitat provided for those species. We can begin to do that for each ecoregion and get to a point where, okay, once you have this list, can we define, based on specific attributes of each of these plant species, which of them will have the greatest functional impact, and match that with whatever the objectives of on-site biodiversity happen to be in an on-farm context. So the idea is to take this list now to a point where we can begin some experimental treatments on farm and identify regional impacts. And so this is just more of the plant listings we use. I'll skip through that. Another thing is looking at surrogate species. So there are certain species we can use to really act as a surrogate for broader ecosystem service functions. We can look at native bumblebees. And one of the things that we have to think about, Frank mentioned this, is not just where those organisms may exist for cover, but also foraging locations, and overwintering sites, reproductive sites. Certain species have different requirements. And it turns out there's been a lot of bumblebee work. The Xerxes Society has done quite a bit of that. And identified that if you want to sustain native bee populations, for example, you have to have 3 particular types of habitat within a 2.5 kilometer radius. And if you don't have those types of habitat who are unlikely to be able to sustain a population of native bees for a long period of time. So we can identify surrogate species for each different level of taxa if we want, and apply that, use those to drive on-site improvements we might make in each different ecoregion. Another take-home message that came through is to select a variety of plants that bloom throughout the growing season so that you are having cover at different times which will suit different species throughout the entire growing season and ultimately throughout the year. We have a very different situation on the dry side of the mountains where we're really only talking about 3 months than what you have here in terms of growing season. So key recommendations and data gaps based on some of this initial work. A functional approach requires really thinking about that bigger system, incorporating on-site work with the off-site surrounding landscape context. Some farms are going to be located in areas where the next nearest habitat patch is relatively far away for a lot of species. So it makes less sense in that particular context to recommend intensive restoration practices where they won't have a lot of benefit. So thinking about this is going to require that we do some really good mapping of existing habitat conditions both on-farm and off-farm so that we can identify where are the priority areas where we're likely to have the greatest initial success. The reason to do that is pretty obvious. One is that you will have success from a biodiversity perspective, but another one is to demonstrate to folks who might want to participate in an approach like this that it can be done and we were successful in these areas. The worst thing you can do is come up with a great approach, particularly someone who's operating in a different field, bring that to you and have it be a spectacular failure. That's going to have a pretty big impact on the process. So another is to develop additional options, thinking through from a protocol perspective, certification perspective, it might make more sense or some sense in certain situations to provide credit for off-site improvements. So if you have a situation where a particular farm is located in a geographic context where it's really isolated from natural habitat, does it make sense to have them invest in on-site improvements versus investing in improvements somewhere else, off-site, which might have a greater biodiversity impact? And then we need to do a lot of replication. So we have just a few experiments that have validated some of the ideas that have been discussed. We need to do more of that. And particularly, what are the effects of habitat improvement by ecoregion, recognizing that there will be variation from one location to the next. So that's what I have for you today.
So today I want to talk about some of the work Willamette Partnership is doing on looking at incentive programs for private landowners. Chris mentioned that our mission is to increase the pace, the scope, and the effectiveness of conservation. And in the Pacific Northwest, with the amount of private land that we have, kind of in semi-natural state, engaging private landowners in conservation is something that we see as really critical to achieving our mission. So one of the projects we're working on is, it's called the Incentives Trifecta Program, and we've been piloting primarily with vineyard managers and on vineyards. So we're using this idea of butterfly-safe wine, kind of leveraging off the idea of salmon-safe wine, but looking very specifically at how the practices associated with sustainable vineyard management can contribute to the recovery and sustainability of the venison butterfly. You're right. If the three of us had a pre-conference meeting, we couldn't have come up with a better kind of sequencing of presentations. You've gotten a great overview of kind of some of the habitat recovery issues that are facing us in the Willamette Valley. We're focused primarily on sort of the oak and prairie habitat in the Willamette, looking at the historical distribution and impacts of both natural and anthropogenic disturbance and development trends. And I'm sure many of you have seen these kinds of maps where you have a kind of pre-settlement distribution of habitat types in the Willamette Valley, the orange being grasslands and prairie, the very dark colors you can see being oak woodlands, and then if you look at a 2011 distribution of that same area, you can see the incredible decrease that we've had. So we're basically down to less than 3% of original remaining habitat in the Willamette Valley. I would love to get a map that kind of showed me the 1950 to 2011 over a time series to just see how rapidly and severely that loss has happened. But this kind of sets the picture and the rationale for why we're all concerned about the management issues in this area. I think we're well aware of the threats or the causes of this. So land use conversion, both for agricultural production and for residential development. Fire suppression, which has resulted in fir encroachment in oak habitat and woodland areas. The role of invasive species, I'm sure all of you are intimately familiar with the issues that creates in threats to habitat quality. And then for oak particularly, we'll get better at this, loss of habitat structure. So there's been a number of conservation initiatives happening over the last couple of years. You've had the BLM working on specific management practices for restoring Oregon white oak. Matt just went into a detailed description about the Oregon Conservation Strategy, which identifies, obviously, prairie and oak habitat as a key habitat type for restoration and protection. You've had nonprofit organizations working extensively in this, so work by the Nature Conservancy. There's been a lot of quantification and evaluation work of the significance of prairies and oak woodlands in our need for restoration. You've got the Cascadia Prairie Oak Partnership that works in southern Washington and a little bit in Oregon. And then you've got various land trusts, and then a lot of actual scientific academic research going on in this area. You also have a number of organizations, both at the state and federal level in Oregon and in Washington, all of whom are actively developing programs or doing research or work to try and explicitly identify what are some effective strategies for recovering these important habitat types. But we're finding that those programs either aren't happening at a scale that's significant enough, or there isn't sort of a collective force or action around it. So one of the projects that we've been piloting is how to develop a working lands approach to conservation and restoration. And I think this fits in very nicely with the philosophy behind something like LIVE or salmon safe certification that recognizes that agricultural production or farm management can be done in a way that's sustainable and that supports biodiversity or conservation objectives. So the kinds of incentives that currently exist to support a working lands approach, you have things like eco-labels or eco-certification that do a really effective job at merging those two sets of activities. We've talked a little bit about ecosystem services, and the idea of ecosystem service markets is getting paid for the production and protection of those ecosystem services on land. So you may have heard of something like a wetland mitigation market, where private landowners produce functional wetland habitat and then get paid for that service. So there's an exchange of dollars for conservation benefits. So those are called ecosystem service market payments or payments for ecosystem services. But what we're trying to understand is what are the combinations of incentives that might bring a specific group of farmers or land managers into the conservation picture. And what we wanted to test was whether or not the existing incentives for prairie, if we combine those, would that be enough of a kind of carrot or incentive to more actively engage in prairie restoration? So we're looking at merging eco-labels, and in this case it's a salmon safe certification. I think most of you are probably familiar with the Salmon Safe organization. They have a farm certification that says that if you follow a suite of best management practices at the farm level, you are contributing to overall watershed health, and therefore the kind of sustainability of salmon populations within that watershed, where the salmon safe moniker comes from. We're also looking at opportunity to create new revenue streams for farm managers, so this idea of payments for ecosystem services or ecosystem markets. And then the third incentive being regulatory assurance or regulatory acknowledgement through ESA compliance. So in terms of the ecosystem markets, Willamette Partnership, my organization, we build a lot of the tools that help both quantify the conservation benefits that come from specific management or restoration activities, and turn those practices into units that could be bought or sold or traded on an exchange. And that wetland mitigation market is a great example of that, where we have tools that take what you do on a particular wetland, the restoration activities that you employ, and it translates that into a functional unit of habitat quality, which we then put a price on. We call that a credit, and those can be bought and sold. And so looking at the application of those tools to prairie conservation benefits. And then finally, in terms of the regulatory acknowledgement or regulatory assurance, the U.S. Fish and Wildlife Service has a safe harbor agreement, essentially an agreement between the landowner and the service for engaging in restoration and protection of habitat that is specific to an endangered species. And so understanding that many landowners might not be interested in a permanent easement or something that kind of permanently constrains or dictates how a portion of land is to be managed. These safe harbor agreements are seen as more flexible opportunities. So it's a fixed term, usually about 20 years, and there's a management plan that's agreed to in terms of the set of management actions that a landowner would undertake to create benefits for endangered species. And it limits kind of what additional encumbrances or constraints can be placed on that land once endangered species are actually on it. And at the end of the agreement, the condition is that the landowner can return it to baseline. So whatever the condition of the land was at the beginning when the agreement was signed, that's all you're kind of responsible for at the end of that agreement. So the service is trying to recognize that a working lands approach needs those kinds of flexible tools, and they're testing out how that may play a role. So we wanted to test how we merge these three incentives into one program to specifically support the protection and restoration of prairie and the recovery of the endangered Fender's blue butterfly in the Willamette Valley. So a little bit about the species, and Matt talked briefly about it. It was listed as endangered in 2000. Its critical habitat is upland prairie with Kincaid's lupin, which is a threatened species. And really importantly, it needs a certain kind of density of nectar to thrive. Its range, native upland prairies in the Willamette Valley, and threats similar to the ones that I've already covered, essentially habitat degradation, loss, and fragmentation. In 2010, the U.S. Fish and Wildlife Service produced a document that's essentially a recovery strategy for the species. So what do we need to do to bring the species back and have it delisted, no longer considered to be endangered? So it specifically outlines the ecological conditions that are needed and some of the best management practices to be put in place to protect, restore, maintain, and connect any remaining fragments of prairie habitat or areas with potential for restoration. And ideally what you're getting to as your indicator of success is whether or not you're able to maintain enough viable populations of Fender's blue butterfly. So this is the kind of policy framework that we're working in, and this recovery strategy gives us the science behind why we're doing what we're doing. So this may not be a very good visual in this room, but this is essentially a map of Oregon, or western Oregon and southern Washington. It shows the range of the Fenris butterfly. And the red areas are populations, existing populations of the butterfly. And the recovery strategy sets out some targets. So it says that in order for the species to recover, it needs a certain distribution and density of high-quality habitat and populations of a certain size so that it's viable over the long term. It's resilient to stress, and it's able to thrive. They call it a functioning network or a stepping stone effective network. And essentially you need areas of a certain acreage, so you need 15 acres of high-quality habitat within 1.6 miles of each other. And you need groups of those across its range. So that's kind of the spatial framework and some of the ecological conditions that we're needing to work towards to contribute to recovery of the species. So the Incentives Trifecta program took the recovery plan that the U.S. Fish and Wildlife Service developed, and it looked at the existing salmon safe certification standards and basically created an overlay to the salmon safe farm standards. So there is now a what we call Salmon Safe Plus, essentially an additional set of management practices that are explicitly targeted to Fenris butterfly restoration. And this idea of a plus or a biological overlay is something that Salmon Safe is experimenting with. So in the Willamette Valley, the Fenris butterfly is the species of choice, and upland prairie is the target habitat type. In another region in British Columbia or in Washington, it may be another species and another habitat type. So they're thinking about this plus overlay as a way to flexibly introduce different specialized habitat restoration opportunities into their program. Just going to move back a little bit. The next thing that we did was to take Willamette Partnerships tools for quantifying those conservation benefits that I talked to a little bit earlier. And it took the ecological targets that were outlined in the recovery plan, and we created a tool that allows you to make that transition from kind of your restoration and protection activities into an assessment of how well a prairie or a patch is functioning for Fenris butterfly habitat. So it's a field-based tool. You go and collect data about the condition of the soil, the plants, the density, the species that you have, how far they are away from other patches, what the threats are surrounding that particular habitat type, and comes out with a score of functionality of prairie habitat, which we can then translate into credits, ecosystem service credits, that theoretically could be bought or sold or traded on a market. And then we looked at the Safe Harbor Agreement and decided what were the key elements that we would take out of the Salmon Safe management plan requirements and merge them with the requirements for a Safe Harbor Agreement so that we now have standards that would allow you to develop a management plan for your property that meets Salmon Safe management plan certification requirements, that meets the requirements for a safe harbor. Everything is quantified by the Willamette Partnership quantification tool. So all of these 4 initiatives working together into one program called the Incentives Trifecta program. So the process right now is to look for landowners who are eligible to be Salmon Safe certified. So Salmon Safe themselves have some basic eligibility requirements that need to be met. And we look at using Willamette Partnership's ecosystem credit accounting system to quantify the effects of the best management practices that are applied under Salmon Safe Plus, and develop a conservation management plan that meets both Salmon Safe and a Safe Harbor Agreement. So the outcome is a property who goes through that process would get Salmon Safe Plus certified, would generate upland prairie ecosystem service credits, and would also be able to enroll in a Safe Harbor Agreement. And the vision was to make that kind of a seamless process. So you've got 3 organizations right now, kind of involved in building this program. But what we really wanted to do is create a seamless process for landowners so that you're only really engaging in one program to get all of these benefits. And the key reason for that, I think, is right here. It's really thinking about kind of transaction costs. So as a manager and owner, if you're needing to go to Salmon Safe and Willamette Partnership and the U.S. Fish and Wildlife Service, and you're having 3 different conversations and developing 3 management plans, it's not a really efficient way to manage your operation. It's not an efficient way to collect data, to do your monitoring program. And we're not generating kind of collectively the kind of data and results that we can then roll up to determine how well we're doing in meeting some of those broader restoration and conservation goals. So the pilot work has gone on over the last 2 years. These are our pilot properties, the locations in yellow, and we're in conversations with 2 more properties. So right now what we're doing, and Matt and I just connected about a month ago, it's really exciting because we're thinking about that same sort of overlay approach as well, as if we're looking at where we need to target restoration for Fender's blue butterfly, what are our high priority areas, and what are the vineyards in this range that are interested in participating in this kind of program. How can we start meeting those multiple types of objectives through this program and start building this functioning network of habitat through this kind of program in partnership with vineyards. So some of the ingredients of success from this program, I've already talked about the idea of 1 pair of boots on the ground. From the conversations that we've had with our pilot participants, I think that's been a really key message that I've taken away from those conversations is with limited time and a full plate, engaging with all these different programs is, it's a time and management issue. And so we're really trying to make sure that a land manager is really just dealing with one person, one organization, and one set of boots on the ground. This idea of achieving conservation objectives through best management practices is something that we're really trying to articulate. So for property managers, for business managers who are basically implementing a management plan that's meeting multiple objectives, it's not that easy to think about, well, what do I need to do for my prairie patch? What do I need to do for my main sort of business activities? What am I doing for buffers? How am I meeting all those different objectives? If we can do the work to create this idea of a set of best management practices, and we can say collectively, if you sort of follow this plan, and if we really think through what this plan can do, then it's really about implementing the plan and making the assumption that what you're doing is having the longer term benefits that we think it does. The third takeaway is really this idea of the strength of peer-to-peer communication. So as a nonprofit, I can walk around to each of you and cold call you and say, hi, I'm from the Willamette Partnership. I'd love to talk to you about what you're doing. The power of one of our pilot vineyard folks going to talk to some of their neighbors saying, hey, this is what I'm doing. We're piloting it, but it's going really well. These are the benefits. I think you should get involved. I've already sort of done the testing and vetting for you, and I think these folks are credible. That's really essential to the kind of credibility and interest that we're finding from other, for involving other vineyards. The other really interesting piece of this, if I can back up quickly, is if you look at this map, we really are going to start getting to the point where we can target spatially the landowners that we want to get involved. And there's been a lot of discussion about the importance of connectivity. If one vineyard is really heavily invested and engaged in a restoration and conservation plan for Fender's blue butterfly, but their neighbors aren't interested or are sort of, biodiversity black hole, then their efforts aren't going to be nearly as successful as if there is this sort of connectivity and neighbor approach to conservation. So I want to touch really briefly about a corollary of the work that we're doing in prairie, and that's around opportunities for oak conservation. So the reason why there's a recovery plan for Fenris and butterfly is because of its listing. So there's a lot of resources invested in it, a lot of science is being done around specific targets that are needed for prairie and for Fenris and butterfly. For oak, not so much. There isn't currently a regulatory driver protecting oak habitat or oak woodland in Oregon. So there's no listed species directly associated with it. There's no kind of critical area ordinance that protects impacts to oak. There's no broad conservation program that landowners and managers can link into and figure out how they should be managing their oak. A lot of it is on private land, so in some of the field work that we're doing in our evaluation of prairie habitat, sort of doing tours with landowners, and they're like, oh, we'll walk by this beautiful oak patch, and I'll say, oh, is this part of your management plan? Are you thinking about how to manage oak? They're like, well, we don't really know what to do with it. It's, we love it. It's beautiful. It's part of, it's in our pictures of our promotional material, but seems like it's dying, seems like it's infested, but I don't really know what to do with it. And so these two pieces together, we're realizing there's a huge kind of inventory of oak out there that's probably not in great shape and probably not being actively managed. And yet it's this really culturally significant species, and it's really a sort of an iconic aesthetic component of the Willamette Valley. I know on my drives up and down 99, that's kind of what gives me the joy and connection to the landscape, is seeing those large patches of oak in the background. So we're starting to think about what can we do to turn that story around in terms of the opportunities for oak conservation. So similarly to our prairie quantification tool, we have an oak habitat quantification tool. That was developed in partnership with Defenders of Wildlife with funding from the Natural Resource Conservation Service. These are the folks that were involved in the kind of advisory committee for developing this tool. So it had private land research, kind of the who's who of folks involved in oak restoration and conservation work in the Willamette Valley. The tool takes into account metrics about kind of the context of the site. So is your particular oak patch near another oak patch, or is it in a conservation zone? Does it have that kind of connectivity opportunity going for it? It collects information about the type of vegetation and the specific species that are there on site. It looks at the types of practices that can be used for oak conservation or restoration. So can you use fire to restore the savannas and the woodlands? Will there be a management plan and monitoring done after the fact? So it takes information about all of that, including risk. So, is it completely surrounded by development or roads, or is it connected to a large natural space? And enters that information into a calculator, and again, it gives you a score about how well that particular patch is functioning to produce oak habitat. And then you can, again, sort of turn those into ecosystem or conservation credits. So we have that tool available. We've run a couple of baseline assessments on our prairie partners, and we're starting to think through what this combination of interest and opportunity could, are there any opportunities for creating sort of a voluntary oak conservation program? So we have a set of best management practices that exist for oak conservation and restoration. A lot of work is being done in that area. We have a quantification tool. We kind of have the passion and the motivation to protect oak. It's really about thinking through what some kind of voluntary incentive program would look like. So we're at the very early stages of thinking about that, and we'd love to talk to anyone who's interested in participating in some kind of oak conservation or restoration program. And I will just close with a couple of final thoughts. So I've already talked about this idea of really targeting best management practices with our conservation goals. A working lands approach, that's an essential ingredient of something that's going to be effective for working lands. This idea of scaling up, so our work happens at a kind of parcel by parcel or property by property level, but this whole idea of aggregating that information into a landscape scale strategy is really important, and I think that's where the work that Matt is doing is so valuable, because recovery does need to happen at a regional scale for it to be effective and meaningful. And then just this idea of a success story. So there's been a lot of interest in the idea of this incentives trifecta program. Hearing about landowners who are excited to be kind of on the cutting edge of conservation. That's a really powerful story that I take forward in a lot of my work. I think it gives other industries who may not be so oriented towards sustainability kind of a model to work towards. So the work that you guys are doing here in Live, the work that our partners and our participating vineyards are doing in the Incentives Trifecta program is just a really great model. You guys are kind of setting the standard for the rest of the agricultural industry. So thank you for doing that, and thank you for your time today.
This is for Matt. Matt, if I'm taking some of the areas that I already have that are under a wide easement, and I want to add some of the sage and possibly some of the other related plants that would be planted around there, when's the best time to plant that?
That's going to vary by species. And so this is where site-specific planning becomes really, really important. Most of the species, there'll be a great degree of variability by species in terms of when the best time to plant is, soil conditions. There are some species that don't germinate well from seed in a broadcast situation, and some species which do. And so you really have to tailor it to the site. So I probably have to know a little bit more about the location.
Okay. Well, I just moved there. So know a lot. So probably the first thing is to just maybe start a survey of what I might have there that matches that. Because I think most of it is just these introduced European species. I mean, that's what we see all over farmlands, mulleins and things like that. And it's just, I mean, all it gives over the weeds of the West. And it's
there they are. Yeah, well, I have all of these. The full color palette.
Thanks so much.
Yeah.
Well, I have a question about inter-row biodiversity. In the past, Live has not allowed this as a management strategy because of the constant destruction of it after every year. And the idea is to have, as Frank said, keep the bar open permanently. So how would you guys recommend doing that so that we could count, for instance, the inter-row biodiversity without destroying it every year, for instance? This is the question, I think, of our program right now. How would you approach that?
Well, as far as I understand, it's also a question of managing the vigor of your wine. So sometimes it's not wise even to incorporate it. So, but I think if you use alternate mowing, you do that already. So you leave one strip in for a longer period, and you could have it like a 4-year period, and you have different strips. 1 year old, 2 years old, 3 years old, 4 years old. It all depends on how to deal with your vigor. So I'm not a specialist in that. But I would suggest to leave it longer on when possible. But eventually you can work it in, but not every year, every strip.
And I think another aspect is just I think it might be the second to last slide, is thinking about plantings that emerge and are productive at different times of the year, so you have staged growth periods. And you have options here that you don't have in a lot of areas, particularly areas which are more arid, in terms of delayed onset and different times of plant productivity. And so I think with a little bit of experimentation, you can get to an approach that would work well in combination with your production goals.
Who else has some questions? Jason, I'm sure you have a bunch.
Well, no, I don't have a bunch.
Only some 10 points.
Only on, no. I was curious as to if you could give us a picture, Frank, of what the typical farm size is, how it is handed down in the Netherlands compared to, and then maybe we could compare it to here, to see if, I mean, a lot of our farms in the Willamette Valley are family farms that have been expanding and growing to large thousands of acres, potentially. I know family farms that are 10,000 acres in this valley. And they have an opportunity to affect almost a single family farm on a regional scale, connectivity and things like that. But when you're 15 acres, say next to a cantankerous farmer who's resistant to these ideas of biodiversity, and you're the lone player, how would you see that these ideas and the way we would affect policy could play out in the 20-year short-term plan, let's say, or long mid-term plan for getting our goals set for better biodiversity and more connectivity? Meaning, we have these challenges. How do we fight them, and how can we? How do you in the Netherlands, as part of the IOBC, dovetail into the government there, like to affect change? Big question. So start by telling me what a typical farm looks like there.
Well, you should imagine the Netherlands is half sand, half clay, half below sea level, half above sea level. And we have farms typically about 100 to 250 acres. So that's the average size that we should think of. So no one is really dominant in the landscape. They all depend on each other. It's a patchwork of farms. So it also means that when you try to do something about in a certain area where you consider yourself as a valuable ecological zone, and you try to develop some additional value or entrance into the landscape, then you see a new development since 10, 15 years that are fairly big developments that many farmers will get together in a sort of foundation.
Municipality or something like that?
No, they call it, they begin as a sort of study club, you could say, but then they really change into a foundation with a juridical form as a sort of nature conserving club, and they try to link in with government schemes, of course, and also with the subsidy schemes of the local community. And it's very much about recreational value also and getting access to the landscape. Because you should imagine, in opposite to the UK, Dutch landscape is not very accessible for the public. You have no right of overpass, or how you call it? Trespass. So making these new nature trails on farming land is something that our farmers are very much interested in, because get the public in, get a dialogue, they open up to it, they see a challenge for that, and that's because the Netherlands is very crowded, so that means that every farmer is directly part of the community, and that the confrontation with the citizens is very immediate. You cannot be remote. You're never isolated in the Netherlands. So it means that there's discussion and dialogue is going on, and they like it, especially this aspect.
And were these farms, did they come together? They like to be involved with the public, but was the federal government, did they require or urge or push in some way that these farms come together? What device brought them together other than just maybe public backlash?
Well, their own free will to do something.
Yeah.
I think not a government scheme, because the government is very reluctant to. They had also the scheme, but always devoted to red list species, to endangered species in conservation terms. Never really to big schemes on vague items like general biodiversity. They also don't really believe very much in that, and they try to avoid coming up with a scheme that they end up being responsible of paying for. So,
yeah, thank you.
think that the difference between this idea of private land and the role of government. And one of the tensions that we work with is what opportunity a policy or a government agency can present for private landowners and when it's seen as a constraint. So I did some work in the Midwestern states looking at carbon markets, and there the government policy, so the government agencies are seen as the enemy. Nobody wants to talk about USDA or NRCS or EPA. Those are kind of four-letter words in some parts of the country. And yet when they instituted a policy that allowed folks to create carbon credits, suddenly it was manna from heaven, sunshine, and we really like federal policy. So I think getting a good understanding about sort of the cultural identity of folks in the space that you're working in, understanding when a conservation incentive program, which is voluntary, presents the kind of driver towards change you're looking for, and when that kind of top-down approach is needed, like when a species is imperiled, and we need radical action to protect it. So I think that's some of the work that we're trying to explore, is what those two different approaches, how effective they can be, but working directly with folks who interpret and understand and reflect them back. That's really essential information for policymakers to have to make better decisions about how to present those opportunities.
Matt, when you think about the type of project that we might do going forward, do you feel like you know yet what, from a scope standpoint, what size of project we would need to do to get meaningful and relevant results? I mean, to be able to look at what's the low-hanging fruit, how many properties does it take to be able to gather that data and actually learn from it? Because I think that's one of the hardest tasks that we face, to try to make a meaningful project here. And so, while we have participating vineyards in the group, it'd be interesting to hear if you've considered that and how close do they have to be together.
So not yet in terms of scope, and I think part of that is the process of jointly identifying a species. So I think the Finnish blue butterfly example is a great example, where you start with the species and its habitat requirements and dispersal characteristics, and that helps you identify scope, both in terms of total spatial extent and then drilling down more narrowly to how closely associated spatially these properties have to be. So I think there's a pre-discussion that has to occur for any kind of pilot application of a new approach, in terms of what species are we going to utilize to drive the discussion forward as an operating for determining scope. And there are lots. The Finder's Blue is an interesting one. Nicole mentioned a couple of different times in her presentation the regulatory driver, and what seems to be a common issue across important multi-party collaborative projects is a regulatory driver, and particularly in ecosystem services markets, where you're trying to create an incentive program. If you don't have the regulatory driver, it's more challenging. The Finder's Blue is a niche specialist, and so what you do for Finder's Blue may not have benefits for a lot of other species. So I think one of the considerations moving forward with a pilot project would be, can we identify several species, umbrella species perhaps, that benefiting habitat for those particular species would also benefit others? And you start there and drill down into their habitat requirements, and that may make you really think about a spatial pattern for a study. It's not quite there yet.
So you're thinking more from looking at this backwards from a species as opposed to, say, habitat type or a particular function or something?
Well, they're related.
Right.
So if you're thinking habitat type, what kinds of things connect those habitat types and allow them to persist? And generally, I tend to think of a species that connects.
Maybe I can add, if you look at your natural landscape, at your ecosystem, potential population of different species. And then you can look at which are beneficial for your vineyard, and you can look at sort of community thinking, because I would not really like to single out one, because you can make, as you obviously demonstrated, some mistakes in that, or mistakes, but you can end up with not having a benefit that you. So this community thinking is a good thing, and then you can say, how does it work on a landscape level, and how can I repeat that, or connect that, or multiply that within my vineyard. And I think that knowledge that you bring in would be very useful to do that. But sometimes these scientists take years before they come up with a solution.
I like how you excluded yourself from
So I've got a question for Frank. Okay. Frank, you were mentioning this superficial tillage, which is something that we're doing every other row. What do you consider the extent of depth? If I'm using something that only goes down, let's say 2 to 4 inches, is that what you're considering the sort of superficial tillage?
Yes. And what it springs to mind now, as long as I can see the light.
Yeah.
You know, as an end. So,
Okay.
So I think that is also sufficiently think in terms of getting the decomposition process going on and preventing regrowth if you really mix it well.
So with our climate here, not necessarily having as much summer rains, at least in southern Oregon, would you imagine there's a better time to consider that versus another?
I wouldn't know, because then I would have to be here and see it. Because I discussed it yesterday, I think with Minnie, that it's also a question of the dynamics of your soil biota. So you always, like the bar should be open above the soil, it should also be open below the soil. So if you give them a lot to eat and a lot to decompose, and then all of a sudden the water shortage is there, and the drought and the sun, and nothing is left to decompose, then they will die off. And that's always a thing. You build up your society, life, abundance, and so you should think, and how can I keep them alive? How can I keep them all year round? It's like to have an extra population to think of, and how to manage them in such a way that you come from the wet period into the dry period and keep sufficient moisture in the topsoil, but also decomposing material over a longer period of time, preventing it from burning down directly to a hard crust. I think you have to think about this type of stuff. It's also good for your mineralization pattern, but it's better spread over time.
Thanks.
I have a question for Matt. And in one of your slides, you mentioned the sagebrush increasing populations to the wasps, which is exciting. But how many sagebrushes would maybe per acre lend itself for this type of effect?
Depends on the surrounding landscape context.
That's true. In the area with the native population of sagebrush existing already.
Yeah. It's a good question. I don't know that we have an answer to the number of individual plants that you need. But for highly mobile species like wasps, relatively small patches can be pretty effective, and they don't all have to be right in the same immediate vicinity.
Are we talking like
I'm hoping that you're in a sagebrush area. That would be the big thing, is that there's an immediate reaction to seeing that plant list. You see sagebrush up there is hosting a lot of beneficial species, and you wouldn't want to be putting sagebrush in this particular ecoregion. It's not something that you would find in most.
Right. No. Just if there were sagebrush around. Yeah.
You know, it can be an interesting species to reintroduce to sites, but small clusters of sagebrush can be pretty valuable, particularly if you're in a landscape where connectivity is relatively good.
David James's research that Matt was talking about in his presentation actually has looked at that pretty extensively.
Cool.
Look it up.
That'd be
You might
nice.
find it really interesting.
Thank you.
Yeah, there's a great report. It's the 2012 progress report from that particular project, and you can access that online. I don't remember if I had a link in my presentation. I think I did put a link in.
Okay.
So if anybody wants that presentation so you can access some of that information, just let me know. I'm happy to share it.
Thank you.
Nadine?
I kind of want to re-ask the question that Jason was getting at about, a lot of our vineyards tend to have a lot of biodiversity in them because we're forested and we don't cultivate every square inch of land. But we're surrounded by neighbors who are grass farmers and other commodity growers that have that continuity between our site and maybe another site that would have the biodiversity to create the continuity that I think we're all trying to talk about. Like, opt-in programs or voluntary programs are great, but our neighbors tend to not respond to those really well. And so, what can we go to our neighbors with and say, what are some incentives that we can give to you to help us achieve some of these common goals for the area? Does anyone have any ideas about that? I mean, this is our biggest problem. Our neighbors,
The greatest thing you can do is demonstrate success and value on your location. That's super important. So anything that you're doing on site, if you can demonstrate success and communicate that in terms of value that would be meaningful to neighboring landowners, that's going to be really important.
But often conservation measures don't equate to monetary value. And,
Sure.
and it usually involves a lot of investment to get the program started, which oftentimes our neighbors don't have the capital to do if they're working on very tight margins in their farm. So these are really difficult questions for us.
It's also a catch-22. I mean, if they're not doing anything, then you might not be able to demonstrate value to show
But
them.
I think it's one of the really awesome things about how Lana has just put these two people in the same room together, because Nicole, not knowing about what we were doing with Matt, had been talking to us individually as landowners, because the viticulture community, as you so aptly said, already embraces a lot of this. It's just how we do what we do. But with oak habitat especially, and it being so iconic, and frankly the grass farmers, a lot of them have some of the low-hanging fruit of what we could be talking about. What she can bring to the table going forward, and how we can connect ourselves with those people via an incentive. An actual, you can get paid to mitigate this habitat. That's how we can really move things forward at pace, I think. And work with people that we've historically not even been able to talk to over a fence.
Yeah.
So.
And in what capacity, I kind of want to ask the group, would each individual landowner be able to say, I'll incentivize my neighbor personally?
Right.
Maybe we'll buy an easement through your property, or, because as we know, the government is slow to act on a lot of things.
Right.
And no offense to people that work in the government, but it's often hard to get our agenda embraced by the government agencies that want to do what we want to do.
Yeah, so one of not one of, but an important ingredient in that whole conversation is being able to quantify some of the benefits. So taking that landscape level strategy and saying, look, this is our broad conservation target. Here's how individual parcels contribute to that. Using numbers, using a science-based assessment tool to be able to demonstrate that you can track and monitor progress towards meeting goals. That all adds weight to the argument that we need a broader program. But I think you really identified a key issue that we need to be thinking very strategically about. So you can have a Oregon conservation program and you can have a voluntary oak program, but how do you make sure that you're capturing a broader suite of actors than just the ones who are already committed? And that's why we think incentives, hopefully with a payment attached to them, is going to be maybe what moves the logjam a little bit. But it will take, probably to some extent, government. They've got the funds that can be used to create some of those payment opportunities. I've long talked about trying to shift some of the farm bill money that comes in for practice-based payments to move towards more outcome-based payments and shift those to kind of different ways of engaging landowners. But I think we're starting to have this conversation, and it seems like we're putting the people and the players together to maybe come up with something that's effective at a landscape scale.
Maybe I can add something to it next to my astonishment that I'm really sitting in a room in America and people talking about government, because you're the country in the world that has the lowest government interference at all.
Doesn't seem like.
And it still doesn't seem like, so that's the spirit. So I think coming in from another point of view, I think these neighbors should be, like you made a choice. You took responsibility for sustainability, and I think the 21st century is about making that choice. So it's not from the freedom of choice anymore, that was 20th century. You have a responsibility to choose in the 21st century. So I think you have to address people and say, what is your choice? What are you going to do? Are you joining this and making things better here, or are you standing aside and not doing anything? And if they then, for instance, say, well, I'm standing aside, I'm not interested, then you can simply ask the question, don't be angry with them, but just ask the question, and is it okay with you if I tell them, everyone, that you unconsciously then all of a sudden you see them, if you do that really, very openly, so don't be afraid, don't be angry with them, but just say, is it okay, we have a next meeting live next week, we're sitting there with 50 people, so if I can tell people that you willingly are not interested in joining us. And then they start thinking, get them to express themselves, get them out of the isolation, get them into a community, let them talk, raise their awareness, and then things will start moving. Because I don't believe fully, with all respect for my neighbors, in the incentive thing of the government. It's also very much a personal motivation thing. And that starts always with the awareness. Look at your own history. Also, some of your members came in on a certain expectation, so otherwise the winery wouldn't buy their wine. But still, if you are part of the program and exchange with your neighbors and colleagues, you start assimilating the ideas and sometimes you start even believing in them and supporting them and becoming an active member of this organization. That's the future, I suppose. So it's an addition to this other approach.
I think you hit on something at the end that was one of the ideas I had kind of going forward. You mentioned how do we as individual property managers incent our neighbors? And is there a mechanism where perhaps you purchase or somehow do things off of your property? That might be a key path moving forward. Thinking about how some of the certification systems allow for and credit off-site improvements as a way to achieve change at bigger scale.
So I can only have my certification if my unwilling neighbor is restoring his pot.
Blame it on your neighbor.
Well, on that note, I'd like to thank our guests here, Brad Times,